现在几点？表定是10点。
应该是10点。
10点开场。
对。
对啊。在上面慢慢
那你这个，那你这边结束那要再发。
好。
Good morning. There's some more seats over here, so if you're not finding any seats, please come over. Hopefully everyone had some great breakfast. We'll be starting shortly, eh? We'll be starting shortly, but if you're not finding any seat, there's still some empty seats over there. Just like go inside, way deep, like into the trenches deep. Good morning, everyone. So we're gonna start for the ETH Taipei today. Well, good morning. So ETH Taipei, welcome to ETH Taipei. It's April 1st. It is still happening, not April Fool's. So glad everyone made it here. Despite the weather and all that, and despite the other factors in the market, we're still enthusiastic here. So a couple things. Well, Gmeow first. Sorry. A couple things first, just for the logistics, right? So this is the whole venue. Right now we're at stage 1, and this year we have a lot of different stuff. Still, stage 1, stage 2, like the speaking places. There's also a co-working space and workshop space at the building number G. There's some booths at building number B, which should be easy to remember. Food networking, live painting is also there. And we also have music stage and co-working space and workshop, etc. Right? So this year we have like much more kind of like interesting things to do around, like you can watch people painting, well, one person painting. And then you can jam actually on the music stage if you're like a musician. So feel free to just go on over and then sign up. There's like a Hana. Where's Hana? Hana's not here. But Hana will be responsible for that, and then you can just like go there and try to jam. And, all right, the other very important thing is the Wi-Fi password. The Wi-Fi password is, well, the Wi-Fi is ETH Taipei, and then the password is ETH 10K in 2025. Woo! Hell yeah! Hey guys, it's April Fool's. All right, so the schedule. For the schedule, this week is pretty packed. And then we're kicking it off with us, the conference. We have the open talk, the conference, workshop, whatever. And then ETH Global is with us here this year. And I wanted to tell you guys a little story, how we got started. Like the whole ETH Taipei thing actually started from, originally ETH Global wanted to host ETH Global Taipei like 3 years ago. And then due to COVID and all that, unfortunately it didn't happen. So we decided to do it ourselves. And then this year, they're coming back, or they finally came. Sorry, that's what she said. And so this is, this is coming a full circle. It's coming a full circle. And I'm very happy to see that. So here's like 2 QR codes. One is the official agenda, and then we have Astro's guide, Block Trends guide, right here. He made an awesome like guide. This one is in English, so if you are interested in kind of like have an overview of like what each talk could be about, this would be a one. All right. Now, today I'm gonna introduce a few things about like Taiwanese culture. So this is called moon blocks. Moon globes. So if you have bought the swag from ETH Taipei, which I should have it with me, then this is the moon block that we have. What it does, essentially, it's a cloud computing device that was invented like, I don't know, thousands of years ago. And how it does, it's very computer science, scientific. It's binary. This is yes. So if you have one side that is flat, the other side that is curved, if it's 1 and 1 like on each, then it's a yes. If it's both sides curved, then it's a no. And if it's both sides flat, then the God is actually laughing at you, saying like, why are you asking this silly question? Like, you may know this answer already, kind of thing. So this is the ancient cloud computing device, and this year we have it in the swag pack, like this. I'll show you guys. Small and cute, all right? So what we'll do right now is do a little bit of cloud computing. Ask the ETH price. How's the ETH price? Will ETH be 10K in 2025? I think it's a laugh. Why is it a laugh? Why is it a laugh? Obviously. So the laugh typically means that, hey, this is something that you know. This is nothing that really matters, etc. And we know we gather here not because of the price. And that's why it laughed. Right? That's why it laughed. We're gathered here because we're builders. Well, we're building the space all together. ETH price doesn't really matter. Now, the other thing that we have is this bag I have right here for the swag. Hey, thank you. And you may notice that there are some patterns around this place, the band here. And this is basically mimicking Taiwanese native snake, which is called the snake of 100 steps. I think this also signifies or signals that, we built the future not in 1 step, but in 100 steps, right? So this is like snake of 100 steps. We keep building, we don't do it in just one go, right? If you look at the back here, there's like some temple, and this is 以太真美妙. It's meaning in English like Ethereum is awesome, as we have last year. So what is ETH Taipei? I would say it is like the snake of the 100 steps. If you look at the pattern really closely, then it's actually a lot of yes, all patterned together. Individual yeses, of the moon block, right? And all these yeses are done by individual people here in the community. What we have done as a community, and this is kind of like a report, since there are some familiar faces here, there's also some like nice new faces here. This is what the community has done for the past year. We have regular meetups, almost free every month. And in total, there's DEF CON that we paused for a bit. There's like Chinese New Year that we paused for a bit. In total, we had 20 highly technical meetups, right? So every month we have one that has like 70 people, 60 to 70 people. And then there's like DeFi TLDR, ZK TLDR, that is really, really in-depth. And aside from that, for people who cannot follow, we actually also have a Substack that basically summarizes all the meetups, the technical content there. Right? And so if you read Mandarin, you can directly read it, and it's a lot of fun. And if you cannot, now AI is a good tool. But you can see that it is highly technical. Like every week, or almost every week, that there's like some highly technical content there just being discussed organically in the community. The third thing that we do is good luck, have fun. This is essentially a project that we send students abroad to different nations and then do hackathons to experience the hackathon like this, like ETH Global. And we also have research grant with mentorship for ongoing and to finish. I think this is mainly by our community member, Nick. And technical blogs, that is done by a lot of folks. There's some English content there as well. I also enjoy them a lot. And guess what? We also have a university course in one of the top engineering schools here. Well, top schools, not just top engineering schools. So this is what we've done in the past year. And obviously, like, we're just gonna keep doing this and then, organically build the community together. And you can kind of see, like, this is a highly technical, nerdy community. And these are done all by these folks that said yes when they didn't need to. And I think that's the key of a community. Communities are a bunch of people who said yes to a value that they didn't need to, they didn't choose to. It may be a more difficult path, right? So contributors, all of these are here. And I would say equally, everyone has its role, which is awesome. And for our sponsors as well, who said yes when they didn't need to, right? So thank you, Portos. Thank you, I'mToken, Zircuit, T-House, Rare Skills, AppWorks, Zoma Protocol, and Gaib. And thank you. I'm sure a lot of speakers are here with us today. You said yes when you didn't need to. And I'm glad you flew over, especially you, sir. Austin, sir. Woo! Yeah. A lot of folks, there's some just limited real estate right here. And so I'm just showcasing some of the most awesome speakers that we have. But in general, we have so many different topics that just comes from, one, the researchers, these builders saying yes to their topic, like for a long time. And then finally saying yes to coming over to Taiwan, right? So we cover topics like DeFi, security, AI agents and Web3, dev toolings, multi-chains, L2, cross-chain intents, and so on and so forth. There's also public goods and open source funding as well, and so much more. And to sum it up, we're talking about the future of Ethereum. Or actually, maybe not. Actually talking about the future of the world. Ethereum is the future. Woo! So, to kind of sum it up, what is ETH Taipei? ETH Taipei is a place I hope everyone has fun, discuss with folks. It's a highly technical, highly nerdy people, and we can innovate together, we can do stuff together. And this is the place to spark your imagination, spark your implementation and all that. If you play a bit with ETH Taipei, censorship resistance. Open it up, open source. Close it up, that's ETH Taipei. And I want to welcome you folks to ETH Taipei. Thank you guys. Now, with that being said, let's welcome Sir Vitalik. Now, here's a Slido. Here's a Slido that you can scan, and then we will take questions. But please, in the meantime, Sir Vitalik, welcome, sir.
Okay, yeah, thank you.
This is for the...
Oh, I see, for the Slidos. Okay, yes. Yeah, well, thank you so much for the kind introduction. So the thing that I wanted to talk about is simple roadmap for layer 2 scaling and security, right? So scaling, a really big topic on all of our minds. So I think, in the last couple of years, we've been going through this really important transition from Ethereum just being this kind of very mostly theoretical thing that relatively few people are using, but lots of people are making a lot of really cool experiments on, to Ethereum being something that supports like very big mainstream applications that are being used by millions of people, right? And I think it's always important to remember that like really Ethereum is being quietly used by a pretty huge number of people today. There's a huge number of people who use it for international remittances. There's a huge number of people that just use it for payments and savings. There's huge numbers of people participating in DeFi. A lot of people using things like prediction markets. A lot of people using things like Farcaster. Also, WorldCoin got to 10 million users. So a lot of things are actually getting pretty significant in terms of scale. And there's a lot of projects in the pipeline that wants to get to a much bigger level of scale, right? Like there are projects that are willing to get to a much, much higher level of users as long as there is space for that. And so to make sure that there is space for everyone who wants to be on Ethereum to actually be able to be on Ethereum, Ethereum needs to scale. And while Ethereum scales, one thing that is really important is we do not want to compromise the fundamental properties that make Ethereum be Ethereum, right? We do not want to compromise on permissionlessness. We do not want to compromise on Ethereum being a global, neutral, trustless, open platform. We do not want to compromise on censorship resistance, and we do not want to compromise on security, right? We do not want to accidentally move back from being an ecosystem where people actually can have guarantees that the assets that they're using actually belong to them into an ecosystem where like everyone is trusting very small multisigs, right? And so scaling and security are really important things that we really need to keep in mind and solve for at the same time. Now, scaling has a layer 1 side to it, and it also has a layer 2 side to it. And both the layer 1 side and the layer 2 side are important, right? And about a month ago, I wrote this article where basically I talked about how there's actually value in increasing the L1 gas limit by something like 5 to 10x, even if you believe that basically all applications are going to be on layer 2, right? So the value of the Ethereum layer 1, at the very least, as this kind of central coordinating point, as a point through which cross-layer 2 interoperability happens, as a point through which Ethereum users go when they're moving between layer 2s, all of these use cases, it still requires L1 to scale, right? So L1 scaling is important, but L2 scaling is also important. And L2 scaling, I think, actually can happen quite quickly, right? So this is the really nice thing that I think is really important to keep in mind, right? Which is that, like, it's taken us a very long time to get to where we are today, but we've actually built a huge amount of technology in the last 5 years. We have tools today that we did not imagine that we would have at all 5 years ago, right? And a lot of the existing layer 2s, Optimism, Arbitrum, ZK Sync, Inc, Starknet, all of these, a lot of them, they're actually using these technologies under the hood. But if you really start to combine the technologies together, you realize that like actually we are in a position where we can scale quite quickly, and we can do so in a way that actually does quite a good job of preserving security. So, step 1, scaling the blobs, right? So last year, in Ethereum, we had the EIP 4844 upgrade, which introduced this concept of blobs. So it introduced this concept of having this separate data space where layer 2s could have their own transactions. And this greatly increased the scalability of layer 2s. It decreased the cost of layer 2s by a factor of about 50. And like it basically really kickstarted the layer 2 ecosystem as it exists today, right? But blobs as they existed as last year, like that, and as they exist right now, they're only the first step in the Ethereum layer 2 scaling journey, right? So the hard fork that is currently tentatively scheduled for the end of April is going to increase the target number of blobs from 3 to 6 and increase the maximum from 6 to 9. So what does increasing the target from 3 to 6 mean? It means that the data space in Ethereum blocks that layer 2s can use to put their transaction data goes up from 375 kilobytes to about 750 kilobytes. Now, how much does 375 kilobytes give you, right? 375 kilobytes, if you divide by, say, about 150 bytes per transaction, then you basically get like about 2,500 transactions in a block, divide by 12, and like you have a little bit more than 200 transactions per second, right? Now, in Pectra, going up from 3 to 6, and so we go up from about 200 transactions per second on layer 2s to about 400 transactions per second on layer 2s. And then at the same time, there's a lot of things that layer 2s can do to improve their efficiency, but really the biggest gains happen after, right? And so in Fusaka, the plan is to introduce this upgrade called PeerDAS, right? And PeerDAS basically means instead of requiring every node in the Ethereum network to fully store all of the blob contents, like we actually start sharding the data, right? We actually start splitting it up, and we start only requiring each node to store a small portion of all of the blob data. And by doing that, we can greatly increase total scalability. So the hope is to get to 48 blobs. There's actually a couple of different proposals. One of them is to get to 48 at the end of this year. Another is to get to 12 or 24 in Q3, and then increase very quickly after that. So there's a couple of different proposals, but in all of the cases, the goal is to pretty quickly increase the blob count. And then if you do that, then the number of TPS that you can do on layer 2 securely goes up over 1,000. Now, if we take the PeerDAS model as it exists, and we crank up the parameters as far as it seems reasonable, we could actually get to 128 blobs. So we could actually get to the original final target for the number of blobs just by using PeerDAS. And then if we get to 128 blobs, then we can get to like something like 10,000 transactions a second. And then if layer 2s do more data compression, we can get to 50,000. But then now the goal actually is to go even higher, right? So the current goal is to get to 512 blobs and then potentially go even higher. So layer 2 scaling, actually pretty simple, right? More blobs, and even more blobs. So this is the scale part, right? I think one other thing that's really important to talk about is the security part of layer 2s, right? So this is probably one of the things that's been the most challenging with the whole layer 2 concept as we've actually seen it play out over the last couple of years, which is basically that in theory, it's possible to make layer 2s that are completely trustless, right? It's possible to make layer 2s that are fully backed by the security of the underlying Ethereum chain. Now, the problem is that a layer 2, and especially a layer 2 that's verifying the EVM, is a pretty huge amount of code. And with a huge amount of code, there's a risk that you have bugs in that code, right? And something as big as an EVM prover inside of a layer 2 verification contract, that's something where verifying that it's secure, like it actually takes a lot of effort, right? And so for this reason, like layer 2s so far have been pretty scared of giving up their multisigs and their security councils. And so right now we have 3 EVM layer 2s that have gotten to what we call stage 1, which is like basically a limited reliance on a security council. And those are Optimism, Arbitrum, and Ink. And I think we can actually be more ambitious and we can actually aim to get to stage 2, right? And the definition of stage 2 is basically a layer 2 that is actually trustless in the sense that the security of the layer 2 would only depend on the code being correct, right? It would depend only on mathematically provable components. Now, you're allowed to have some components that are not mathematically provable, but those components have to have only a limited amount of power, so that if the provable components are all working correctly, they can override the other components, right? So basically, if you imagine a layer 2 with multiple proof systems, then fully trustless proof systems have to take up a more than 50% share, right? So this is where we want to go, right? We want to get to layer 2s that are actually trustless, that are actually provable, that are actually running based on all of these principles that we want layer 2s to run on. Now, the challenge today is, from a usability perspective, optimistic rollups are still quite a bit ahead of the ZK rollups, right? And with ZK rollups, there's two major challenges. One of them is cost, but the cost is very quickly decreasing. The other challenge is that ZK is still a relatively immature technology. It's still, especially at this level of complexity, has quite a high risk that there's some amount of bugs. And so we don't want to fully rely on ZK. But then there's also another problem. The other problem is that with an optimistic rollup, you have to wait 1 week to withdraw, right? If you have an asset inside of an optimistic rollup and you want to withdraw it to layer 1, you have to wait 1 whole week. Now, the way that this works in practice for regular users, right, is that regular users are not going to be actually withdrawing directly, right? Regular users are going to be withdrawing through intents, through market makers, through a cross-protocol ERC 7683, like all of these second layer things, right? And then it's market makers that will be actually doing this like round tripping between layer 1 and layer 2. But the problem is that if these market makers have to wait 1 week every time they withdraw, then this is very capital inefficient for them, right? And if it's capital inefficient for them, then the fees that they're going to charge to regular users trying to move coins between different layer 2s are going to be high, right? And so what we really want is we want layer 2s to go down to having, let's say, maximum 1 hour withdrawal time. And I think in the long run, we can actually get to layer 2s having a 12-second deposit and withdrawal time, and we'll talk a bit about that. But let's get down to 1 hour first, right? So 1 hour basically means no need to, like, none of these sort of challenge response systems, right? Like, optimistic does not work. Basically, you need something where instead of waiting to make sure that nobody says that a particular state root is incorrect, you have proof systems that just tell you that the state root is actually correct, right? So we have to balance these two different concerns, right? Basically, on the one hand, we don't want to rely too much on immature technology yet. On the other hand, we also want to be able to withdraw from layer 2s quickly. And so the design that I think actually does quite a good job of balancing all of these constraints at the same time is this thing that I proposed a couple of days ago, which is a 2 of 3 between optimistic, ZK, and trusted hardware, right? So optimistic, we all know, it's the technology that Optimism and Arbitrum are using, and optimistic rollups, an optimistic proof system, you have to wait 7 days for it to give you an answer. ZK we know, and then trusted execution environments, basically, there's things like SGX, there's TDX, there's a whole bunch of these, right? Basically, they require having trust in a hardware manufacturer, and also they rely on this security assumption that like a particular piece of hardware has not been broken, and breaking into hardware is generally much, much easier than breaking a cryptographic algorithm, right? And so it's a very different kind of security assumption than cryptographic assumptions, but it's one that we can kind of add into the mix, right? And so the goal of this kind of design is basically that we're not leaning on any side too much, right? Basically, trusted execution environments, they can give attestations of correctness immediately, right? And so because 2 out of 3 proof systems, they can give you an answer immediately. In the normal case, you have instant finality, right? In the normal case, a layer 2 submits a block, and then immediately you get a ZK proof of it, and you also get a TEE proof of it. Now, in order for layer 2s to be stage 2, in order for layer 2s to be trustless, you don't want like things like TEEs and security councils to actually control the thing, right? If you have a layer 2 that's like actually controlled by things like TEEs, then like it's not a layer 2 of Ethereum, it's a layer 2 of Intel, right? And so but what this architecture does is it limits TAEs to 1/3. And so if the code is working correctly, it doesn't matter if the TAE breaks completely, your funds are still safe, right? And then also at the same time, it still keeps 2 out of 3 in the hands of relatively mature technology. And it's basically making a bet that ZK and TAE, as they're like, the risk profiles that they have are sufficiently separate that we're not going to get a ZK breaking and a TAE breaking at the same time, right? And so, or at least being broken by the same attacker, right? The argument is that the things that cause them to be vulnerable are very different from each other. The people that are good at finding those vulnerabilities are very different. And so it's like basically as uncorrelated as you can get, right? And so, well, like my argument is that if you have this kind of architecture, then it basically actually achieves all of the security properties that we want to the best level that we can today. And at the same time, it will let us be able to natively withdraw from layer 2s within an hour. And I actually think it should be possible to get EVM layer 2s up to something like this within 2025. So that's part 2. Now, part 3, right? Let's talk about fast finalization. So ultimately, I think you should be able to deposit and withdraw from a layer 2 within 12 seconds, right? Layer 2s should be moving closer and closer to just being like Ethereum shards. What is a property that you would expect from an Ethereum shard? You would expect to be able to move things between different Ethereum shards very quickly, right? And so you should be able to expect to move assets between one layer 2 and another layer 2 very quickly, and you should be able to expect to do that natively, right? Why natively? Because, well, if you can do native movement from one layer 2 to another layer 2 within 12 seconds, then you can do things that you cannot do with intent-based protocols, right? With intent-based protocols, you can move ETH from Optimism to Arbitrum. You can move USDC from Optimism to Arbitrum. But you can't move an NFT from Optimism to Arbitrum. Why? Because, well, you can't have like a market maker have a second copy of an NFT on every layer 2 so that they can front the liquidity. It's impossible because there's only one copy of that layer 2, right? Or of that NFT. And so can we have cross layer 2 native movements happen within 12 seconds? Can we have everything within the Ethereum world be doable natively within 12 seconds? I think the answer is yes. And I think there is basically 2 things that need to happen for that. One is that proof systems need to become faster, but I actually do not worry too much about this because I think there's a lot of incentive for that to happen already, and actually layer 1 already needs the same thing. But the other piece is basically layer 2 is submitting to layer 1 needs to be much cheaper, right? Today, layer 2 submitting to layer 1, it has a gas cost of like over 500,000. And the reason is that basically every time you submit a proof, verifying the proof is very expensive. And so the thing that I think we need to do is we need to create aggregation protocols, right? We need to create protocols where you have many different layer 2s. Each layer 2 submits a proof. And actually, you need to keep this limited to layer 2s. You can combine everything, right? Layer 2s, privacy protocols, account recovery, wallet, ZK email, anything that uses a proof, you can basically have users submit, and then you have one aggregation protocol that takes, say, 100 different proofs, and it replaces them with one single proof of all the proofs. And so you have 100 different protocols where instead of all of them needing to submit 100 separate proofs for 500,000 gas each, they can make much smaller transactions, and you only need one aggregate proof to verify that all of them are correct. This is infrastructure that can be built, and if it can be built, then the submission cost for a layer 2, submitting a state root to a layer 1, can go down to probably below 10,000 gas. And then if you do that, then it actually becomes economically viable for every layer 2 to commit to layer 1 and to have finality in every slot, right? And so this, I think, is how we can solve that part of the interoperability piece. So I think there's also other interoperability pieces that matter, right? So L1 S-load is really important. L1 S-load basically means that layer 2s will be able to read layer 1. And this basically means that you could use layer 1 as this central store of information. So we can have like key store wallet data on layer 1, you can have Oracle data on layer 1, you can have a lot of different things on layer 1. And then layer 2 is become able to just read that data for free without having to pay gas for it. Then we talked about ERC 7683, so users being able to transact with intents. And a lot of this is also just work on the wallet and user experience side, right? So I think like a lot of the time when people talk about problems with Ethereum layer 2s, like a lot of the time the problem isn't even like the base level technology, right? The problem is basically that there's a lot of these inefficiencies in how wallets are designed. And so if you currently are on Arbitrum and you want to move to Optimism, you have to click a bunch of buttons, you have to figure out how to use a bridging protocol. It's very annoying, right? And so what we need for all of that stuff to appear much more native. We need bridging and sending to just look like the same operation to the user. And these are all things that chain-specific addresses, intent, 7683, all of this kind of work actually does, right? So these are kind of the technological directions that I think we need to go in the next probably roughly 1 to 2 years to try to make push layer 2s really to the limit of their potential, right? And I actually feel pretty confident that if we work hard, we can get all of these things done within 2 years, right? I think if we want to be realistic, then if we look at scaling the blobs, we can probably get the first half of this done in 1 year, and then the second half of this done in 1 year. If we look at this 2 of 3, like I actually feel quite confident that we could get this done in 1 year. The thing that will take longer, I think, is doing formal verification, pushing ZK proofs to a much higher level of security, and then eventually in like maybe 3 or 4 years, we can actually get rid of the optimistic, get rid of the TAE, and we can actually have extremely secure zero-knowledge proofs of protecting all of our layer 2s and protecting our layer 1 as well, right? But this is something that will just take some more time. And then fast finalization, like this, I think, realistically probably will take 2 years, right? I think realistically this just has much more dependency on zero-knowledge proofs being relatively safe. And I think if we focus on this, then this will already be able to get the layer 1 to layer 2 native bridging time down to 1 hour. And then I think this is like a natural stage 2 of the roadmap, right? Basically bring that bridging time down from 1 hour all the way down to 12 seconds. So if we have all of these things, right, then basically we get to this future where any kind of layer 2, like basically functionally actually does, feel like an Ethereum shard. You actually get the kind of hyper-scalable Ethereum experience that we're actually talking about. And at the same time, we're also in a very good position to use a lot of these exact same technologies to start scaling the layer 1 as well, right? And so if we have these things, then I think we can really start to get layer 2 up to a much higher level of security and at the same time a much higher level of scalability. And we can actually say we have an Ethereum ecosystem that actually is ready to serve applications and build things that actually go and benefit like 10 million, 100 million, potentially 1 billion users. And we can feel confident that we're not making any compromises on security, censorship resistance, or permissionlessness while we do that. So thank you.
All right, thank you, sir. There are some Slido questions that you may want to check out. So this one.
Okay. We have cheap block space now. How do we get the devs to come back and build actual apps? Yeah, I mean, I think, okay, so here's the thing, right? I think this idea that we have cheap block space, for devs to feel confident building serious applications, and like especially if you think about like large enterprises building institutional applications, you can't just tell them we have cheap block space now. They need to feel confident that there will be cheap block space now and 2 years from now, and if their application goes 100x in number of users, right? Like, and if you think about the Ethereum L1 right now, Today it's cheap, 3 years ago it was expensive. Like, as an app developer, how do you know that Ethereum L1 is not going to become expensive again in 1 year from now, right? Or even if you build an app today based on the assumption that a transaction on layer 1 costs 10 cents, and then your own application succeeds, and then just because of your own application succeeding, it clogs up Ethereum and fees go up to $2, then like that's also a risk for you, right? And so I think we really need to avoid the trap of saying like, oh, everything is cheap, therefore we need to stop worrying about scalability, because it's not true, right? And so, I think basically we need to get both layer 1 scale and layer 2 scale up to the point where as a large scale application developer, you can actually come in and you can feel confident that transactions will be cheap enough for you, even if a huge number of other applications become extremely successful on top of Ethereum, and the price goes up to 20,000 and everything goes crazy at the same time, right? I think if we just kind of sit back and say things are cheap today, then like that's not good enough, right? Like we have to actually provide that level of guarantee that developers can trust. And I think if we do, then like there are plenty of people that are actually willing to come and build those apps. So that's a big part of the answer. Another part of the answer is that I think as a community, we do need to be more imaginative, and we do need to like actually try harder to think about some of these application layer questions, right? And like, I think, the layer 1 infra stuff and layer 2 infra, it continues to be important, right? But I do think that in terms of like percentage of mind share in our community, the layer 1 and layer 2 stuff probably should decrease somewhat, and the application layer stuff should increase somewhat. And the reason why it's important, I think, is because like, if we as an ecosystem don't lead the way and figure out applications that people want to use and that are actually good for users, then like we'll just still be sitting here in 2028 and we'll still basically have like presidential meme coins and Ponzi's, right? And like that's not a future that I or I think most of us actually wants to see for Ethereum, right? And so I think like active leadership and active thinking of applications both that people want to use and that have business models and that actually make the world better, like I think we can do more in thinking about this. And I mean, I think the higher quality of infrastructure that we have now means that things that we try today can actually be tried at scale, right? Like you can go directly to a much larger group of much more normal users, like you're not just stuck within this like group of 500 enthusiasts, right? And so I think we do need to think about both sides.
Yeah, probably just two more.
Okay.
So this one.
Could you please elaborate more about stage 2? Why would we need an optimistic way if we're doing ZK? Yes, okay, so the definition of stage 2 is basically a stage 2 rollup is a fully trustless rollup. What does that mean? It means basically that it's a rollup where if the code does not have any bugs, then everything is guaranteed to be correct. Like there isn't some set of humans that can go in and like flip a few switches and steal all of the money, right? So if you're stage 0, then you're basically just a multi-sig, right? The proof system doesn't matter. There's like a group of 8 people, and if they all decide to like click a button, they can take out all of the money, right? In stage 2, it's fully protected by the code. Now, the reason why I suggested we need to have both ZK and OP is because right now, I don't think we're quite at the level where we can afford to fully trust a code, because there's still the risk that code has bugs, right? Now, how do we deal with the risk of bugs? We have 2 different proof systems, and these 2 different proof systems, they have very different risk profiles that are very disconnected from each other, right? Like the situations in which a ZK proof would have bugs and the situations in which an OP proof would have bugs are very different, right? And so that's the argument for having ZK and OP. Now, the argument for bringing in a TEE as well is basically that we want something that in the normal case, again, lets you finalize in 1 hour, right? ZK proofs, they can finalize in 1 hour. OP proofs have to wait for 7 days. And so what basically, what this would end up doing in practice is in normal operation, what happens is Someone proposes a state root, ZK signs off, TE signs off, it's finalized, right? And like the OP thing never actually gets called. The place where the OP thing gets called is if either the ZK has a bug or the TE gets broken. If either one of those exceptional situations happens, then the ZK and the TE will give answers that disagree with each other. If they give answers that disagree with each other, then you have to wait for 7 days for and then the OP proof system acts as a tiebreaker, and it chooses what will hopefully be the correct one of the two.
Right. I think just for the time, let's wrap it up.
Yeah.
And yeah, let's give a round of applause for Sir Vitalik.
Thank you.
And right now, sir, if you can like sit there and perhaps we can have like a group photo together. For folks that are in the at the door, please do come on in.
Okay.
Thank you, sir. Yeah. All right, we're gonna go for it. Have a big smile. 3, 2, 1. All right. Very good, sir. One more. Change the position a little bit. 3, 2, 1. All right. All right. Hey. What was that? Okay. All right, we're gonna go for a camera, right? 3, 2, 1. Ooh! All right, let's do it one more time. Perhaps let's shout ETH Taipei together. Is that okay? All right. We good? Why not? 3, 2, 1. ETH Taipei! Okay, panorama. One more. One last one, just making sure everyone is in, eh? Yep. All right, thank you. Then there's so perhaps we can just be here and then waiting for them to come in. All right, so next up, we actually have the panel also with Sir Vitalik and then the EF folks, the EF dreamers. That's coming right up. Fireside chat with Ethereum dreamers with Sir Vitalik and then Xiaowei Wang and Joseph Schweitzer. Let's wait a bit for the setup, but perhaps in the meantime, we can also just go on. One of the top questions on Slido is actually why you wear masks, sir.
The mask is fun. Come on, it's April Fool's Day. We need to have fun.
Yeah, it's April Fool's, guys. Yeah. Right. Right, we are good then. Xiaowei. Oh, there we go. Please welcome Xiaowei on stage. Joseph, Sir Joseph, welcome. Go for it. Yes, sir. Both way works. Very chill. All right, Sir Vitalik. All right. I can see you. Oh, actually, you have the mic, so that's good.
Yeah, I have the mic. Yeah, so...
Test. All right, everybody's mic'd. Hi. I'm Joseph. I'll be your moderator for this panel. I do PR work with Ethereum Foundation, and we're here to speak with Vitalik Buterin and Xiaowei Wang, who is the new co-ED of the Ethereum Foundation. But today is a very special day. As you've all likely heard this morning, marks one of the larger deals in the history of our industry. Blockstream announces that Bitcoin, soon Bitcoin 2.0, will solve its security and quantum risks by becoming the future settlement layer for rollups, now L3s, and Ethereum's native L2 stack. Vitalik, you announced a few minutes ago in a blog, you'll be moving over to Blockstream for the next 4 years with Tim Bako, who will steward the Bitcoin core dev meetings. What are you looking forward to working on most at Blockstream? And what can the Ethereum ecosystem expect from Adam Back's incoming leadership as part of this trade?
Yeah, no, I mean, I think it's going to be very exciting. You know, we're going to get Ethereum and Bitcoin to merge together, as was, of course, the original Satoshi's vision, as was proclaimed by Craig Wright. It's, you know, it's going to be exciting to see, you know, Ethereum going back to proof of work and Bitcoin going to proof of stake. And, you know, we get to do both of those transitions at the same time. I mean, I think, you know, it's, like the crypto space should just like do more fun things for the world, right? And it should just like scale and it should do technical things. It's like, you know, it's kind of like just like how Elon just keeps on launching starships and like, you know, sometimes they blow up. Like you just do like fun technical stuff and like you know, you give people, the world something to watch and be excited about. So yeah, I mean, I'm excited about this partnership with Blockstream.
Have fun. All right. On a panel like this, we would usually jump right into technology questions like that one, but real. Happy April Fool's Day. But Xiaowei, I introed as the new co-ED at EF and a co-organizer at ETH Taipei. And Vitalik navigated an intense transition period with everything you guys have seen posted on Ethereum Foundation's blog and everything discussed over the last few months. So, I have a lot of questions. I'll run through as many as I can, but feel free to time keep. If you give me a 5-minute sort of notice, or and we'll run through as many of these as we can. But let's start with EF. Xiaowei, your role and Tom's is a new chapter for EF management. Can you share more about your priorities, what you plan to work on?
So hello everyone. Yeah, so before the co-ED role, I was a researcher at the EF, and I am a community builder in East Taipei and other Taiwanese community. So I think this role changing to me, like first I will have many new areas that I will have to be familiar with more, like not just the protocol research. So I think that the priority thing to me was like, okay, first we have to review like what we did is not good enough, or what we did was good, then we should keep going. So like I think the first month, like not first month, first 2 weeks we did was like in this process. And after that, I think the most important thing is to increase the capacity of management team. I think the new chapter of the EF is, it's not about, so like now we have 2 co-EDs. It doesn't mean that we will like change largely about, I mean, we will shift our focus to somewhere largely. I think we're more about like how we can do more in the new area. Because I think this management change in somewhat reflects like 2025 could be a more crucial year, and then we need some new inspiring to the EF inside, and hope to fully like these vibes will also spread to the ecosystem. So, like say, like the team capacity increasement, and then I think next thing is like we would, like it's not rebuild, but at least for me, myself, and Tomasz, like we will enhance our communication and connection with the community. Like we've been in this industry for over years, but I think taking this position means that we will need to have a broader vision to the ecosystem. So I think that's two of our recent capacity. And after that, we will have a more practical plan about what exactly things we would need to do as soon as possible.
Got it. Thank you. And to Mudeng's adoptive father, what? You guys, he gets it from you. What does it mean to do, as Aya says, what only the EF can? And can you lend a little bit of insight into how the EF works, the interplay between management, for example, and research? There was a lot of, during the stress of the last months, people thinking that they could bring in, you know, someone like Danny and they just sort of define a roadmap as ED. And I think this was some, you know, some more insight might have been helpful there into what research does versus what management does versus what the board does and so on.
Yeah, and so the way that we think about the Ethereum Foundation's role is basically that it does the things for the ecosystem that are really valuable and important for the ecosystem to both like thrive and prosper in general and to continue to support Ethereum's underlying values, but particularly those things that would not just happen automatically on their own in the EF's absence, right? And so if you think about say building DeFi applications, for example, right? I mean, DeFi is great, right? But also there are plenty of other people who are willing to create DeFi applications. And so the EF itself does not need to have a team doing that. But on the other hand, if you think of something like paying security people to constantly look over the clients in different parts of the protocol, that's easily something that the ecosystem would underinvest in on its own, and so it's the EF's job to participate in that. Or another aspect of this might be that there's some layers of infrastructure where if they were left up to independent actors, they might be designed in a way that's more proprietary than it should be, that's more dependent on either extra tokens or centralized actors than it needs to be. And so you really need or something like the EF can be really valuable and actually putting the effort into creating a version of some part of the stack that's really built on open standards that supports permissionlessness and censorship resistance and decentralization as much as possible, because building something like that by default does not have any economic interest, right? And so those are some of the EF's goals. In terms of the EF's operation, it's this very loose collection of a lot of different teams, right? The research team has been actually quite autonomous for a long time. The Geth team has been quite autonomous. PSE has all kinds of different components to it, right? And so the job of leadership, I think, is to make sure that all of these different pieces have the resources that they need to make actually do their job. Also to keep an eye and make sure are there things that need to be expanded on? Are there things that were necessary before but are not necessary anymore, or that the ecosystem can do on its own? Are there new areas where the foundation needs to step in and become more involved and create more teams and basically have this kind of coordinating function? So to me, that's what leadership is about. And then aside from that, like we generally try to be hands-off, and like we try to like focus on nurturing and focus on like being supportive to the different teams inside and outside the foundation, and like do what we can to maximize the extent to which everyone can productively collaborate.
Got it. And as a sort of follow-up, although this can go to either or both of you, while the EF isn't Ethereum's government, some view, some believe that for holding Genesis Ether, it gives the org some public accountability. What do you think about that dynamic of sort of how that role changes over time?
So what role do you mean?
EF's role and its sort of responsibility as either responding to or representing public wants versus having fulfilled the launch of the network role and sort of now existing to do what it sees as being in the network's benefit.
Right. I mean, I think like in general, we should avoid being sort of too stuck in the past, right? And I think we should always kind of revisit Ethereum from the perspective of the present situation and basically ask the question like, okay, here is where Ethereum is at now. Here is its current level of technical capability. Here are its technical concerns. Here are some of the social concerns in terms of whether it's like alignment of incentives or centralization risk or something else. And then here are the unique properties that the EF has as an organization, and how can we best leverage those properties to try to improve things, and also to try to, I think, kind of maximally move the ecosystem to a place where, like, ideally, like if the EF has some function for some amount of time, like maybe at some point, it can figure out some way to arrange the ecosystem so that the EF doesn't need to do that function at some point in the future, right? So, yeah, and I think in general, like we need to keep an open mind, sort of not be overly influenced by the conception of like how we thought of the EF in 2014 or 2019, but keep in mind Ethereum's values, keep in mind the philosophy's position, and basically ask like, what is the right thing for the network at the current time?
Got it.
And also, just to add that it can be both true that the EF treasury was backed up by the Genesis crowdfund, and then by the ICO, but also that the EF was established by Vitalik and other people. Like it was like at the beginning that they set the firm like goal and the philosophy and core values for what the EF should be, what the EF should do. So I think just we have to balance between like what the by the time, like since the EF is not the central, not the main player in the ecosystem, and at the same time, I mean this dynamic change it must happen, and it's happened because the EF is doing good job, right, to distribute to empower the powers, and then at the same time that we still have to remember like what the EF's core role is and what can EF do and other entity couldn't do. I think that's important.
Okay, it's a tough balance. There's I think it's definitely easy to see how a lot of foundations look a lot more like companies that aren't going anywhere. And then in Bitcoin there used to be a foundation. I think I gave them $20 once. But
yeah, well, there's two kinds of failure modes, right? There's like the foundation that looks like a company, and then there's also the foundation that looks like a retirement fund.
Yeah.
And like we see plenty of both in the crypto space. So I think we should not be either of those two.
Do you see any others that are trying to play the same sort of long-term game as ETH is? Application layer, layer 2 layer?
And I think there's like a lot of different like projects and teams that aspire to this ideal of like trying to think about having a long view, but at the same time, you know, the question is like, is which approaches are actually going to work? But in like to me, the EF is there to exist in combination with all of these other like projects, you know, like applications, layer twos, zero X Spark type entities, other people within the Ethereum ecosystem.
Okay, so we're going to skip ahead and talk about Ethereum now, but thanks for the EF commentary. On the network, Vitalik recently said that we're now at a pivot point where Ethereum moves from a more experimental technology in its early days into a global, incredibly neutral settlement layer for the world. To either of you, we can start with Xiaowei, but what is a tangible example, whether it's securities markets, identity, real-world assets, anything that might look like wider success to you in the future, and what does it look like in practice? Like, can you give a dream scenario of a way that real people are using the network 10, 20, or 50 years down the road?
Good question. I think okay, so it will based on like we will have a very scaled network in layer 1, and hopefully also layer 2 will have a more healthier ecosystem and applications will be built on more on layer 2 than layer 1 for the spatial use cases. And if we think about the long-term vision, then the application layer will be much more like visible, important, and closer to people's real life in the long term. So I think this is, for example, like transactions should be, for the basic payments, it should be like seamless, and it should be embedded to our current payment use cases. Then also like, okay, you should be able to, for the user, you should be able to feel like there's no blockchain when you use it. It's just the normal payment solution. And then identity, and this identity will also like combine to the privacy solutions. Like you should be able to choose like what kind of data you want to share with in all the use cases. Yeah, and zero knowledge will be largely like, well, including this embedded into our life, like, but also like you don't need to learn about like what zero knowledge cryptography is, that you can just use it, I think.
So largely it's that owning your own keys and sort of managing your own security exists for those that need it, but for a lot of people, when they tap in pay, they'll be using digitized versions of, let's say, nation-state currencies that are institutionalized, this kind of thing.
Yeah, also like I think it largely will be depends on the wallet user experience, like to make people don't feel any crypto, any blockchain like inside this. You need to have a really good wallet experience, and it doesn't. Maybe it won't be called wallet in the future.
Yeah.
It'll be just like your, you know, like right now there's like WeChat or like Line in Taiwan, and so in the future it'll be maybe you don't feel this is a wallet, it's an integrated application, and you have many small applications inside it.
That's a call to the app developers out there. There's a lot of work to be done, and abstract things. To Vitalik, you can answer on this one a little bit as well, but If not, I have a controversial layer one question for you. Okay. There's a lot of debate out there about the L1's value capture mechanisms. So some researchers talk about blobs capturing value and this being sort of a main feature of future L1 revenue. And the other side says that DA will be sort of negligible and that we need to look at other L1 scalability paths and other L1 sort of fee capture mechanisms. Where do you fall on this today? And I don't want to make it so that you come down so strong that it sort of steers research in one way or the other. But
so I think like there's a lot of uncertainty about where the value of cryptocurrencies comes from, right? And there is the school of thought that it's about like the fees. There's a school of thought that like actually fees don't really matter, and it's just about sort of the moneyness of ETH, or like sort of the centrality of ETH as this kind of big payment and collateral asset inside of the Ethereum ecosystem. I mean, I think in general, like I would prefer we be agnostic between those different options, and we try strategies that can help ETH, the asset, prosper in all of those different scenarios. And I think the big commonality that lets us do that is basically that, like I think for ETH, the asset to prosper, the Ethereum L1 does have to do things, right? Like I think if the L1 just becomes this kind of hyper minimal thing where like you just have a few hashes submitted into it, the problem is like even if you can theoretically make a story about how there's this ecosystem and ETH can have moneyness in that ecosystem, like the problem is that all of the other actors in the ecosystem, their interest is not to cement the presence of ETH. Their interest is to cement the presence of their own assets, right? And so we're seeing, USDC-based economies on layer 2s. We're seeing like there are like layer 2s encouraging issuance of assets directly on their own chains, and like all of these different things, right? And the challenge is like if layer 1 has a very low level of power, then like the ecosystem has no choice but to do all of those things, and the result of it will be that the layer 1 does not collect significant fees, and you get all of these different actors whose incentive it is to keep on eroding the moneyness of ETH and kind of replace that with other assets, right? And so I think the more that this is a big part of the reason why I do think that a good roadmap for Ethereum has to include a strong role for a strengthened L1, which includes more blocks, and it includes more L1 gas, and it includes more of these L1, L2 interoperability features. Because if you have that, then like that creates more opportunities for the L1 and for ETH to have more of a role in all of these dimensions.
And brief follow-up on L2 interoperability. Are you seeing progress? We talked about things last year like address format work. There's calls ongoing now, but I think how extensive of an effort that is still something to be seen. Any early thoughts on this?
Yeah, I mean, it feels like it's making progress. It definitely feels like there's broad agreement among a lot of things. I mean, the open intents framework exists. There's definitely wallets that are integrating it and that are integrating chain-specific addresses already. There's definitely been a lot of kind of quiet progress in terms of rallying everyone around a common set of frameworks under the hood. So I'm optimistic about how things will go forward from here.
Got it. Okay, Toshawe, I think we have time for maybe two more. We'll see. But largely, we talked first about EF's role in sort of pushing credit outward and sort of outward the ability to act as an ecosystem. Where do you see the Ethereum ecosystem today as most healthy or self-sustaining? Where is it still overly dependent? And where do you see our ability to impact those things?
So I think, so Ethereum ecosystem is getting, I mean, the scale is much more bigger and we have much more leaders in the ecosystem. But I hope we will have more decentralized leadership within the ecosystem. Like we're doing good, but it's for my perspective and also like inspired by this Aya's Infinite Garden, is like we should enable more players to join it, and that's not just from the current ecosystem, but also from the outside. It's like how can we onboard new leaders to join the ecosystem? So I think that's what most from generally we should do more.
Okay. Since I got the 3-minute marker, I'm just going to see if we can do a lightning round with a few of these. All right. In regions where stable coins are gaining traction, how do you see Ethereum or decentralized technology catching up with centralized chains that got early adoption? To Vitalik.
Yeah, and I think one, just having better and competitive UX, and then also two, I think like pushing forward on even new kinds of asset issuance, like even alternatives to existing, I mean, like USDC and USDT type things, and better opportunities for people to do more things with to like save and build their wealth.
Okay, to both, and you can give as short of answers as you'd like. If somebody builds DeFi on or stablecoin payments on a blockchain that is, let's say, 99% owned by a company, 1% given out to their favorite validators, is it DeFi? But it supports the EVM.
I think that's like C DeFi, right?
Stage 0 DeFi.
Stage 0, yeah. Okay, one application type or specific app, if you have any in mind, with regional or global implications that deserves more focus. This is give a shout out to somebody.
With regional or global focus?
Yeah.
So that means any focus at all?
Yeah, either or just a type of application.
Okay, the whole like space of things like ZK email and Anon-Adhar and TLS notary, like basically kind of like things that let us read Web 2 inside of Web 3 and thereby import Web 2 trust anchors into Web 3. I think that gives us a lot more options for how to create more security for regular users, but at the same time, like actually, yeah, still have more self-sovereignty, because like you would be able to combine like different combinations of these things and not be controlled by one actor.
I think decentralized social media, like I mean, right now I think the conversation was pretty centralized in some basic community, and also like it's for Asia. Community, it's like there will be somewhat barrier between these tribes, and then I think it's better to have this like first like it's the decentralized platform, but also like how we coordinate between this decentralized hub within the community, like how can like East Taipei people be more connected to the world, and also like how not just East Taipei, but also like I think Asia and West and Europe. That's the three like regions. Like I think there should be some more innovative ways, more creative way to community.
Okay. There's some work being done in the decentralized social media space. We could probably see more. So everybody here, run over to the ETH Global event at the end of the week and build another stack. All right, thank you very much. I think this ends our time, but thank you, Vitalik, thank you, Xiaowei, and keep building.
All right, thank you guys. Thank you guys. Thank you, Joseph. And yep, go ahead. All right, for now, so that kind of like concludes our Vitalik session and then the EF session. From now on, like this is the one of the buildings, right? The main M building. The other speaker will be at the A2 building. So we have like two places that you can listen to speeches to. And yeah, for the next one over here, we have Sir Martin. Sir Martin from Zirkit. And so all you guys have heard about like the rollups and stuff, like how to provide like better user experience. And Martin is going to talk about EIP 7702 on Ethereum and rollups.
Plug in my laptop. Do you have a cable somewhere?
You need to see your laptop.
Yeah, I just need HDMI somewhere.
You will show
Yeah?
your platform at the way.
Okay, and do you have a clicker for me?
Clicker.
We should probably wait until the hour, right?
No?
For the people.
Yeah. How it is.
And I assume green is before.
That one I have. Okay.
Probably wait for the schedule. Thank you. I made like a super long talk about 7702 for like 45 minutes. And then I gave myself the goal to like, cut it down to here and to Pragma and to have 2 different talks and hopefully squeeze out of it one more talk at CC. And I don't know if I cut it down too much. So it's kind of.
All right, about to start. Let's get ready, get seated. All right, so let's welcome Martin from Zirkit, talking about EIP 7702 on Ethereum and rollups. Fun fact about Martin, he was actually one of the auditors that audited Ethereum before, right? So, pretty insightful. Let's welcome, give him a round of applause.
Awesome. Thank you, everybody. Thank you to organizers for having me over here. It's an amazing experience to be in Taipei again. I very much enjoyed last year, and I always love coming here, bringing the best content that we currently have. So I will be talking about Ethereum EIP Proposal 7702 by yours truly, adoptive Mudeng's father, and some other people. And this is just the excerpt from the EIP itself on the GitHub. I'm just really gonna skip over it, because I will talk about what is actually in the EIP a little bit later. So this talk is about 7702, and specifically it should give you some inspiration about what you can build using EIP 7702, because as I heard, there is a hackathon upcoming in this town. So what is EIP 7702? When I try to understand new concepts, I always look at them and try to come up with some sort of a Martin digestible translation. So here is Martin's digestible translation for what 7702 actually is and how you should think about it, okay? So when I think about 7702, I envision this scenario. I am submitting a transaction. It's a regular transaction, the same transaction that you are submitting these days on Ethereum. It has some payload, it has some sender, it has some message value, and so on. But for 7702, with this transaction, you can submit an additional thing. You can invoke something that is called set code for some accounts, together with this absolutely regular transactions, okay? So what is set code? Set code is this new thing that comes with EIP 7702, and it effectively allows you to delegate the functionality of your externally owned account to a smart contract. And this this account will then start offering the interface of the smart contract, and you will be able to call methods on it. And anybody else in the Ethereum ecosystem will be able to call methods on it. And then this account will start executing these methods, but it will execute them in its own context, specifically in its own storage, okay? So whatever writes into slots we will have, they will be actually writing into the EOA's storage. But other than that, that EOA, it's still gonna operate in the same way as it normally did before this EIP 7702. So there will be a private key known for this account. Somebody will hold this private key because they needed to sign that original authorization for the delegation, and they will be able to invoke transactions out of it as if it was their externally owned account. Okay, so this is what is EIP 7702. How it is implemented in practice. So in practice, we are actually using a different EIP. It's EIP 2718, which tells us how we can create new types of transactions. So with this 7702, we are essentially creating a new EIP 2718 transaction, and we give it a specific transaction type. It's going to be the constant 4. Okay? So in practice, that means that when you take this EIP 7702 transaction, you will get a serialization of a whole bunch of stuff. But really, all this black stuff, it's actually what was originally present in your very regular, normal transaction. All of this is present in all the transactions that we have on Ethereum, except this one part, and that's the authorization list. And this is the one thing where we invoke those set codes. So authorizations come in this particular format. It's a serialized list of lists. And in every single authorization, we have a chain ID and an address that a given externally owned account agrees with becoming, and the nonce. And then we have a signature of that account agreeing with this authorization. And what we do during execution, so before we execute this very regular, normal, ordinary transaction, we actually go through this list of authorization, and for each such tuple, we understand that the signer, that's this Y parity R and S value, this signifies that the signer authorizes this address to execute within the context of their EOA. And then if anything is calling this EOA, then we write the delegation designators into the code space for this EOA. So we give it some magic constant concatenated with the address. And then if you are executing any kind of code that calls this EOA, all code executing operations then know that they should sort of treat this as a pointer and load those instructions from there. And as I said, this all happens, processing of these authorizations, that happens before my very normal, ordinary, regular transaction gets to processing, okay? So this is how you should think about EIP 7702. So, what is it good for? What could we build using such a mechanic? I'm gonna start with an example that I very often hear about. And yeah, it's a good example, so why not? So imagine that you would like to authorize somebody to spend some of your funds. Right now, you can do that for ERC20s, right? They have this approval method. There are also some other primitives such as the permit functionality and so on. Not every token implements that. So here you have the ability to allow somebody to spend funds from your account, and that ability can come in multiple ways depending on how exactly you implement. So you can give them some constant amount of ETH that they can spend one time, or you can give them a constant amount that they can spend every period of time. Or you can tell them, hey, you can spend up to 10% of my account, and you can also use something like ERC20 tokens. That seems pretty useful, right? Because you can start developing new things with that. You can develop some monthly contributions. As I said, you can give some allowances to various roles. We live in the world where we really like AI agents, so imagine giving an AI agent the permission to spend 10% of your funds every single week, because that's what you want to do. You can develop subscriptions, and so on and so on. However, while people actually speak about this use case, I have never seen anybody showing any kind of useful template or even an example of this template that you should delegate into your EOA to achieve this. So this is it. This is how it would look. You basically need to have two methods. One of them needs to enable you to record who are the people who are authorized to call this other method, right? Who are the people who are able to spend funds from your account. You can notice in here, I have a clever trick. This actually, let's read it out loud. The first line requires that the message sender for this transaction is this particular smart contract or this particular EOA. That is here to make sure that nobody else calls this function without you being aware of this. The second one is transaction origin equals address this. That means that the call actually, again, came from this EOA. You probably want to add some reentrancy and whatever, but the goal is that in here, you actually update who is allowed to call this other method. So this is some kind of ACL type definition. And in this other method, well, hang on, I talked a lot about spending 10% or 10 ETH or whatever. There are no primitives that are ready to use for you. This is actually where you will have to code the function from scratch. So you probably will want to check that this message sender who is currently trying to spend funds from your account is authorized, right? But then, it's kind of a double-edged sword. You have no primitives that are ready for you to use. That means that you can make up any primitives that you would like. So you will have to do some accounting. You will have to invoke the storage of the smart contract, record how much was withdrawn over time by that particular spender, and how much they are allowed to withdraw, and only allow them if this actually falls within the bounds. But this is roughly what you would do if you wanted to spend 10% of your funds. Well, here I have a gotcha. There is one thing, there are actually multiple things in EIP 7702 where the EIP itself doesn't take care of them for you. The one that I decided to include in the talk as an example is the storage. So when we remove delegations from from your externally owned accounts, the obvious behavior that you expect here is if you are able to set some delegation, you can also remove it, right? So we remove delegations by overriding them with empty delegations with like 0 address. Well, when that happens, we actually do not clean the storage. So whatever you would put into these storage variables inside of your EOA now, that actually will remain there, right? Nobody deleted it. So that means that we can have some surviving records if we then redelegate the account again, and the user might not expect that. So in this particular example, we have that spend methods, and I have decided to add some mapping that says, hey, those are the spenders who are authorized. Well, if you delegate this, register some spenders, then undelegate this, and then delegate this again, those spenders will still be registered. So careful about that. Another thing that could also happen to you is 2 different delegations. Let's say that at the beginning you delegate your account and you record this evil person who should never, never, never be able to allow to call this, right? If you later change your implementation and you actually decide to, at this very same slot, encode the owner and then say, holy, only this person is able to call this particular method, well, then you clearly have a clash, right? In one case, you didn't want this. In the second case, that's the only person who is capable of doing this. So careful about this. Careful with the trick. So since we are coming up with a hackathon, I also wanted to, share a little bit of how I would do things differently. So here's my personal trick for separating storage of smart contracts. If you want to, you can use something like a simple key value data store. So this is a smart contract, right? It just records mappings of strings up into some byte values that you can typecast to whatever you want. And it has 2 methods, getter and setter. Well, if you wanted to use it, you would use it somewhat like this. You would have a data store that would be a reference to this instance of the data store. Then you would have some initialization step where you would always create a new instance. And thanks to that, then these gets and sets, they would operate in the context of this new instance of a data store. That's a smart way of quickly wiping out the storage. Okay, just waiting for all the pictures. Good. Cool. But I want to go back to EIP 7702 because there is actually much more cooler stuff that we can do with this. So, as a motivating example, I chose this. This is another thing that I very often hear from various friends in the space. Hey, listen, man, after this EIP 7702, there's like approve and use the ERC20 tokens, that construction is going to be gone. We will never, ever need to use anything like that. But that's a misconception. So let me elaborate. When you are using ERC20 tokens, you are somewhere here, you are the user, right? You are actually issuing 2 transactions to 2 separate smart contracts. If here is your ERC20, imagine USDC under there or USDT. The first transaction that you're actually doing is this arrow. And there you're calling approve and giving somebody the permission to spend your money. Then you invoke second transaction, and that actually goes to somewhere else. It goes to that somebody who you want to be able to spend your tokens. So here, imagine Aave or your favorite DeFi protocol instead. You, in fact, send a transaction over to there saying, hey, I want to deposit some funds. So this smart contract on its own is going to reach out to this ERC20 token and call another method, right? So if you wanted to simplify the life through ERC or EIP 7702, you would arrive to a situation that looks somewhat like this. Your account would become delegated to some smart contract. And you would want in this smart contract to have some function that allows you to deposit into Aave atomically or in a transactional way. So this function itself would first call the ERC20 and then within the same execution it would call Aave and Aave would reach out in here. And that would be a way how to make that happen without having to do approve and transfer from as 2 separate transactions, because then you or anybody else who has the privileges to invoke this deposit Aave method would just make that call on your EOA, okay? But here I'm going to argue that this is actually not what we want as a user experience. Imagine the universe that we, definitely used to live at, we probably still live in, where we have a whole bunch of these DeFi protocols, right? So you have Aave, you have Compound, you have Uniswap, and you can just keep piling and piling and piling. So you would probably want your delegated EOA to sort of be smart and be able to interact with any of these protocols, right? But their interfaces, they actually differ. In Aave, you have something called Aave Pool, and you call a method called supply. In Compound, you have something called C tokens. When you want to deposit funds, you actually call a method mint. And in Uniswap, you have some, I don't know, deposit LP or whatever, or increase liquidity pair position and such. The point is, every single one in this naive approach would probably need to have, its own invocation method. And on one hand, this is a really cool idea, because what I would really like to have for myself is this super cool wallet where I can just say, deploy here, pull from there, deploy over there, and so on. But what I definitely do not want to have in there are all these pre-coded methods. What I would much rather have is one generic method that can interact with everything, right? Because what would that allow me to do? That would allow me to essentially position the integration between DeFi protocols from the level of smart contracts and EOAs to the level of front ends, which is exactly where this EIP becomes insanely powerful. So what I'm saying in here is that we actually need some universality and batching. So here is this holy grail type method that I'm going to show you on the next slide. Is actually not invented by me, but it's heavily inspired by the guys who invented the multi-call smart contract. And you can actually find some other examples for this somewhere else, for example, in Gnosis Safe Wallet. So this is roughly what this universal structure would look like. I'm going to encourage you to check the original multi-code code so that you can actually understand all those possible nuances. But in simplicity, you would have some data type that would signify a call. Here I'm simplifying this to only have the target, that's the to destination, and the bytes that actually serialize the call data, right? We know that we could have multiple options. We could have value attached to it. We could also care about whether this should fail or not, and so on. So you would probably have like 3 or 4 such data structures inside of your template. But then, in your aggregate function that universally executes these calls, you would just accept a whole bunch of these calls, and then you would do what we did before. You would, first perform some authorization. Let me tell you, allowing any arbitrary third party to issue any kind of smart contract calls directly from your wallet. That's a really, really bad idea without authorization. So some part like this, you would probably want to protect against reentrancy, but then everything else is just execution of the call through the primitives that Solidity as the language and EVM currently allows. Okay? This allows us to interact with any kind of DeFi protocol. So as I said, you would probably want to take some security crack at it. So first of all, yes, make sure that all those calls that are coming into the execute or aggregate method, that they are actually signed, because as I said, you would not want to allow an external party to make up and craft calls that will be called on your account. That is a bad idea. You would probably want to embed in some anti-replayability measures, such as chain ID, so that if you sign something as an intention for one chain, it cannot be replayed somewhere else. You would probably also want to implement some kind of a non-system, right, so that you can guarantee the order of calls in which they will be executed. And you would probably also want some global invalidation nonce. If you realize, oh, hang on, I actually want to cancel all of these things so that you can do this. But overall, it's actually really strong, right? Because if you imagine that we have a whole bunch of wallets in some ecosystem that are delegated to this universal executor, you can actually start doing cool things. You can start building relaying services that will accept these calls, right? These payloads for the invocation of the method. And you can start like playing them on chain by funding the gas for the user. And that allows you to abstract away a lot of chain complexity, such as gas, such as transaction confirmations. And essentially you move the entire user experience from the wallet and user signing and interacting, with a dApp through a wallet into Web2 space. And I say that this is good because through decades and decades of internet, as humanity, we have actually learned how to make pretty good user interfaces in Web 2. I don't think that anybody is currently complaining about the experience that we are able to achieve, in general in Web 2. So this actually gives us the opportunity to let people spend more time in those apps and those crafty interfaces rather than signing their transactions and waiting for some processing. As a side note, I gave you this weird mixture of programming technique, of some template, of a different template that can be used for something else. Really, we are actually opening a completely new chapter in the Ethereum space, right? We have a new way of transacting. And while some other and original or more original ways of transacting were fairly standardized up to this point, this one has not yet. So if you also do not know what to do during this hackathon, maybe take a look at standardization. Try to craft some EIPs. I think that would be a really cool outcome for the hackathon itself. But other than that, EIP 7702 is actually already available, so you can also hack with it. It is available on the Ethereum testnet networks that have already upgraded to Pectra, so you will find it on Holashki, you will find it on Sepolia. There is also a brand new testnet hoodie, so grab some of those links, and if you feel like it, do something really cool with EIP 7702. To fulfill my duty, EIP 7702 is also coming to Circuit. We will have it live with Pectra as far as the timing goes of the call from the last week. This is currently scheduled for April 30. And all the transactions that will be played on Circuit, regardless of whether they are EIP 7702 or not, of course, will be protected by our feature sequencer level security. With that, I would like to thank you for the attention. Please build something cool with EIP 7702. Talk to me if you do. Otherwise, have a great hackathon. Thank you.
Perhaps we have some time for some questions. Is there anyone wants to ask some questions? Just giving out the, yes, sir. That's a long way to go. Oh, sorry. Let me go for this one first. It's just close. Thank you.
Hi, I'm sorry. My name is Kenneth. This might be a very newbie question, but I'd like to ask, for EIP 7702, why did you choose to introduce a new transaction instead of working it off through a smart contract?
Okay, so first of all, I didn't choose. The account abstraction topic has been around for quite some time. EIP 7702 is actually not the very first flavor of account abstraction that has arrived to Ethereum. We also have the 4336 EIP. They are a little bit different. They are made to sort of work together and operate together, but it has been a long-standing problem that smart contracts in Ethereum, and by the very vanilla definition of EVM, they just cannot transact. Sorry, they can transact, but they cannot have this additional logic of code that always, was meant to be zero. And it was insanely prohibitive because while you can send a transaction to an EOA, it will never, ever, ever be able to deal with it or react to it or respond to it. It's just like this passive element up until the moment when some version of account abstraction shows up. So there are use cases that you wouldn't be able to achieve without it.
Sorry, I want to know about if 7702 will be danger like permit to somebody let you allow the attack contract. You add the attack contract to you allow list.
Yes. I think the answer is yes. It's a little bit broader, yes, than just this particular instance. There will certainly be malicious smart contracts that will phish users to delegate their accounts to. There will certainly be some templates that will contain bugs. There will certainly be like elements and aspects that the users have not anticipated. For example, the clearing of storage, right? That is not so well anticipated. So I think the answer is yes. What exactly they are gonna look like, I think that we are still, let's say, waiting. We know that this potentially can be dangerous. The truth is, if you do nothing, if you never delegate your account, the security of it will not be impacted. There is nothing new that can happen without your explicit approval or signature or something like that. So somebody will always have to, phish you or make you delegate a malicious smart contract or do something that shouldn't have been done in the first place. But if you do nothing, then your account is gonna remain exactly the same way and the safe way how it is right now.
So in my understanding, the 7702 biggest risk factor is that actually it breaks a lot of trust, might break some trust assumptions for other contracts which were pre-deployed, which never expected EOAs would have a code. And I took a look myself and we found some really interesting cases on that. So for you as one who was looking on the security side of that standard, how much of those deployed contracts or the existing projects you feel you've analyzed and looked through?
So there is actually a line about this inside of the EIP itself. Somewhere there is a section that speaks specifically about the construction message sender equals transaction origin, right? That one used to be sort of used to detect whether we are at the top level of execution or whether there could have been, some smart contract manipulation of state of the blockchain happening prior to the call and so on. So situations like this certainly might be broken. I say might because you said that they should be analyzed, and this is where I'm with you 100%. I think it depends case by case. Even this transaction origin equals message sender, it actually can remain a meaningful construction because it still signifies something, right? It still somehow restricts the execution. So, you know what? I don't have a clear answer. I think that something certainly can be broken. If you are operating a DeFi protocol, you probably should take a look into it. I also have this secondary opinion that if transaction origin equals message sender was kind of the only thing that is protecting your protocol, maybe the protocol has some, inherent logic flaw or design flaw. So depends. I think that people actually need to scrutinize it quite deeply, and if needs be, then exit those protocols that are now vulnerable.
Yeah, so I was actually referring for not just origin, but say transaction hash, bytecode hash, which in my opinion was absolutely secure to use. And it's actually quite legit way. And then,
yes,
and then it was actually one of the concerns.
Yeah, that semantic also changed. That's correct.
What feedback have you heard from wallet teams on the 7702?
So I heard a lot of feedback through the ears and mouths of our ecosystem team at Zirkit. The general number one item of feedback is that the wallets probably will not, allow the users to sign blindly any kind of authorizations. They will also care a little bit about, what users are doing. If, I don't know, they are delegating to a general proxy, that's really unsecure, right? Because the proxy can upgrade itself without the user knowing and so on and so on. So I think that the wallets will play a fundamental role. I think that this will be a little bit weird model where we have kind of an organized, effort from multiple parts of the ecosystem and multiple levels of the ecosystem, but I think it's for a good cause. I think that it can produce something pretty strong.
Martin, thank you. And let's
Thank you.
review. All right, everyone. So thanks for joining us. So that wraps up the morning session for today. Now there is lunch at the food court. So there's the food building, if you remember, so, like right there, and probably just like walk there. Then you'll find it. So there's lunch served. It is limited, so first come, first serve. Do go there. And if you need like something else to eat, the metro station is right there. There's a lot of restaurants over there. And I hope to see you in the afternoon.
Hi everyone, grab your seat soon. Our next talk is about to start. This one.
Now, before we get started, you might want to do a little bit of stretching. We're going to have some audience participation in this one, and you might need to raise your hand suddenly. I don't want anyone to pull a muscle or break a bone. Those are actually sex toy paddles. Those are spanking paddles. Yeah. Thank you, sir. The beatings will continue until morale improves.
That sounds like
That's what she said. I was like,
I also hope that not too many people will attend. Sometimes jokes are funny because they're.
I think you guys keep it light.
It's like sneaking.
Was that something you had anticipated, or was that just an off the cuff?
I'm like off the cuff. Like the whole thing was off the cuff. Like, I have kind of like off the cuff. Like everything that I said is like really off the cuff.
Pretty cool.
I love the swag, by the way. We were talking about them at dinner last night. And it was actually kind of cool because I was at one of the temples yesterday during the day, and I saw people do that.
Did you try it?
Well, I didn't try it, but I hopped on ChatGPT, and I was like, why are people doing like the watermelon? And it was like, those are actually blue balls, and here's how you use them.
Actually, that's the first time I know how to pronounce it. Yeah. Say
Oh, same here. I had to like.
And so the fact that you know you give them a swag, that's cool.
And you can always like step by.
Because speakers don't get swag. Okay. As long as someone else enjoys it, I'm happy.
I was like.
How many of you guys?
So the swag was first come, first serve.
One is for it's like for the not first come first serve. There's like a ticket like flag. Flag.
If I had done that, I would have.
How computing device?
Yeah, not computer device. It's ancient.
Yeah. Like literal cloud.
Good afternoon, everyone. Up next, I'm thrilled to have Lauren from Paddle Battle giving a talk about web impactful auctions, Web3's opportunities in revolution public good funding. Let's give a round of applause to Lauren.
Hey guys, my name is Lauren Harkness. I'm one of the founders at Paddle Battle. And damn, our logo looks good on the big screen, right? Yeah. They've got a cool setup here. So Paddle Battle is an impactful auction platform. What does that mean? It means we auction off cool shit and we donate the money to public goods. So what are we talking about when we talk about cool shit? Well, for example, right now on Paddle Battle, we are auctioning off a DApp node home with your own PFP printed right on the lid. It's not a sticker, it's a custom print job, only available on Paddle Battle. Vitalik, I know you're here today. Milady. And where does the money go? Well, we do fundraising for some of Web3's best public goods projects, including GiveEth, Protocol Guild, Glow Dollar, Roadkey, and many, many more. But I'm not here to shill Paddle Battle to you. I'm here to talk about novel auction mechanisms. And even better, I'm going to talk about the dominant theory or dominant strategy for winning each one. But first, you're probably thinking, who cares? Well, let me give you 2 good reasons. First of all, there's a shit ton of money in impactful auctions. This is something which was pioneered in Web 2, and it's already a $7.5 billion business. And it's growing at a tremendous rate. It's projected to reach $17 billion by the end of this decade. And it's companies like eBay which are doing this, right? But this is a perfect opportunity for us to onboard users and organizations to Web3, because Web3 can do this better. Think about it. We have the global payment rails, we have smart contracts for automation, and we have trustless verifiability. And by bringing impactful auctions to Web3, we're bringing the right type of people. We're bringing value-aligned people, not the scam coins and the pump and dumpers. We're bringing people who actually want to build something of value and make the world a better place. The second reason impactful auctions are awesome is because we're slaying Mulak. For those of you who don't know, Mulak is the god of coordination failure. Whenever you have a group of people who have a common goal but aren't able to achieve it because they lack incentives or the proper coordination structures, Mulak is summoned. But one of the things I love about impactful auctions is that we bring together these 3 different actors, and they all act in their own self-interest, but somehow magically public goods funding appears. So let's break it down. Well, the auction host puts up a prize, and the bidders pay good money for it. I'd be willing to pay good money for a DApp node home with a custom PFP on the lid. I think most people would. The projects, it's pretty self-evident. They need money to continue their good work. And you might be thinking, but what about the auction hosts? They're donating the auction prize. And yes, that's true, but they're getting something much, much better in return. Number 1, they're getting incredible branding as a leader in public goods funding. Number 2, they're getting a viral marketing campaign. And number 3, in some cases, they're getting a sales lead generation tool. And last but not least, everyone is incentivized by the fact that it's fun. So, this is part of a growing trend in Web3. There's lots of amazing projects and protocols which are thinking about how we can align interests and allow different actors to act selfishly, but somehow create public goods funding from the mix. I don't have time to get into all these amazing projects here today, but I'm actually talking at ECC in Cannes on this exact topic, so I hope you'll see me then as well. Okay, so impactful auctions, right? We auction off cool shit, and we donate the money to public goods. And when you think of auctions, you probably think of this guy, $10, $10, $20, $20, $30, $40, $50, right? This is what we all think of when we think of auctions. A guy at a podium with a hammer, people in the audience with paddles. That's where the name paddle battle comes from. But this is just one type of auction. This is called an English auction. And the rules are pretty simple. It's open, meaning all the bidders can see all the bids in real time. It's ascending. It starts low and the price goes up. And of course, it's winner pays, meaning the winner pays and gets the prize, and everyone else pays nothing and gets nothing. It's simple, it's plain, it's boring. So we're going to talk about novel auction mechanisms. And I see you in the audience. You look like this guy. You're super skeptical. The thought of new ideas, of innovation, it makes you uncomfortable. That's why you're here, right? No. But some people are skeptical. This guy was skeptical. He said, humans are very bad at some game theory problems, and Paddle Battle exploits that. People can play stupid games and win stupid prizes if they want, but I'm not a fan. To which I reply in the words of the immortal Gandalf, "Do not take me for some summoner of cheap tricks. I am not trying to rob you. I'm trying to help you." To which he replied, "Oh, I didn't realize the proceeds were being donated. I'm much less bothered." So open your minds, but more importantly, open your wallet. And this is where audience participation comes in, okay? So I'm gonna auction off a $1 bill. I've got it in my back pocket, but both my hands are busy. This is a special type of auction called an all-pay auction, and the rules are really simple. You bid, you pay. Regardless of whether you're the highest bidder or not, you pay. Okay, so let's start the bidding at 10 cents. Do I have 10 cents? Anyone want to buy $1 for 10 cents? You, sir. Yep. Okay, we got 10 cents, 20 cents, 20 cents, 20 cents. Do I have 30 cents? 30 cents? Yep, we got 30 cents. 40 cents? 40 cents, 50 cents, 50 cents. Okay, now we're rolling. Do you see what we just did? Because everyone is paying, the sum of all of the bids, which you're gonna pay, by the way, is now more than $1. So what did we just do? We created the infinite money glitch. And this is awesome. This is public goods funding, money printer, go. Brrrr. And you may be thinking, well, this is just a silly example and we're humoring him. It's just $1. But in fact, on Paddle Battle, our very first auction, we auctioned off 100 USD Glow valued at $100. And the highest bidder, well, she paid $202. I have more time than that. I know I do. We started late. And in total, we raised $600 for DeFi Scan. And the reviews were outstanding. In fact, the highest bidder said, worst deal ever. So, the dominant strategy for an all-pay auction is do not play. Because you may think that buying $1 for 10 cents is a good deal, but then you get on this slippery slope, and pretty soon you're paying $202 to get $100. Fortunately, you're funding public goods in the process. The next type of auction I want to talk about is called a penny auction, and the rules here are a little bit more complex. Each bid must be 1 cent higher than the previous bid. 1 cent, 2 cent, 3 cents, no exceptions. But each bid comes with a bid fee of $1 that you need to pay. And each bid resets the timer. When the countdown timer counts down and reaches 0, the auction is over. The highest bidder pays their bid and gets the prize. But notice something here. The highest bid is always going to be 1% of the bid fees. So the majority of public goods funding here doesn't come from the highest bid, it comes from the bid fees. And these auctions basically feel like this, because the countdown timer is ticking, ticking, ticking down, and then someone submits a bid at the last second, and it starts all over again. It's horrible, it's agonizing. You will lose sleep. I have lost hair. It's painful, okay? But it works. This auction, the DAppNode Home auction, which I mentioned earlier, it's live right now, and you can bid on this DAppNode Home device. This is an old screenshot, but by now we've raised more than $400 for Rotkey, and it's been going on for about 2 months now. Fortunately, some big brain on Twitter did the math and correctly pointed out, if everything goes according to plan, this auction is going to last 33 years. Oof. So, what's the dominant strategy for winning a penny auction? The dominant strategy is you do not play to win, you simply play to prevent others from winning, which means that you are going to bid as seldom as possible. If the countdown timer is ticking down, 1 minute, 30 seconds, 10 seconds, and someone else submits a bid before you do, perfect. The countdown timer resets and we go again. You sat that one out. You saved your energy. You saved your resources. You lived to fight another day. Okay, let's talk about another type of auction called a sealed bid auction. This is very similar to an English auction. It's ascending and winner pays, but the key difference is that all of the bids are encrypted during the bidding period and then decrypted at the end of the bidding period. And this means that everyone in the auction, both the bidders and the auction host, are blind. They don't know what anyone else is doing until the end of the auction when everything is revealed. And for this, we're using the new Shutter API. Shutter is a commit and reveal threshold encryption as a service protocol, which basically allows us to do the encryption and decryption in a decentralized way quickly and easily. And our devs are currently working on it, and you should see this on the Paddle Battle website soon. But sealed bid auctions are actually really cool. First of all, they're better than English auctions. They generally have 9% more participants and raise 166% more money. Even better, they have a really intuitive and wholesome dominant strategy, which is you just bid your perceived value. And if you win, you got a deal. And if you didn't win, well, maybe someone else valued the item more than you did. And that's fine too. But there are lots of other auction mechanisms we're looking to explore, including popcorn bidding, team auctions, yield auctions. And if you have ideas about auction mechanisms you'd like to test out in real life, come and talk to me and we'll implement them because it's fun. So that was a brief overview of Paddle Battle and impactful auctions, which I remind you are, we auction off cool shit and donate the money to public goods. If you're interested in participating in any one of our auctions, or you're interested in collaborating, or if you have cool shit to auction off, head on over to paddlebattle.auction or on Twitter, Paddle Battles. Thank you.
Thank you, Loring. Do we have any questions from the audience? I think we have time to take one questions. Okay, let's give a round of applause to Loring. Let's keep the momentum going. For our next talk, we have Sabrina from Lido talking about Lido's path to improving decentralization. Let's give a round of applause to Sabrina.
Hi, good morning, everyone. My name is Sabrina. Today, I am going to talk about Lido's path to improving decentralization. Okay. Yeah, I'm a contributor at Lido in the node operator mechanism workstream. And so I will talk about what is Lido and basically walk you through what we have built in the past 2 years and just then where we are now and something we are building in the future. So what is Lido? At a very high level, Lido is a liquid staking protocol, and currently we have over 9.3 ETH staked with us. The protocol is basically a middleware that connects stakers and node operators, and it is governed on-chain by the Lido DAO. So, at the very beginning when Lido was launched in 2020, there was actually no modules, and there was only something called a node operator registry. And this later becomes the curated module as we call it now. So back then at the start, if you want to become a node operator in the curated module, you basically need to wait for like onboarding window to open. And when there's onboarding phase, anybody or any organization are welcome to submit the applications. And in the application, you basically will share things like about your organization, about your team, and how do you run your infrastructure, and about your security practice and this sort of information. And then basically Lido contributor would then review all the applications and then trying to set up meetings with all the different teams. And so not to just know the team better and also to understand what their experiences are. It can be outside of Ethereum as well, like any other proof-of-stake chain. And also we will look at how do they, like the validators they have run, how do they perform in the past. Then, so you can imagine this is a pretty time-consuming process. So in the past, there had been a total of 5 onboarding rounds for Ethereum, and we have onboarded 39 different organizations to join the protocol. So here, I have chosen 2 images to just show like some characteristic of this module. So in the top image, it's basically how the stakes is being shared through all the other operators within the curated module. And the second screenshot down is that as I described, so basically this is a quite selective process, like to choose how which node operator we work with. So it's so we work really closely together. And I think something this is pretty cool is that because of the way it's working, we were able to really push how the client diversity has been improved. You can see at the bottom, it was the blue bar is the ETH client usage for the gas, and it from 84%, and you can see after 1 year of progress, it went down all the way to I think 46%. Yeah. So in order to address the kind of shortcoming of a single modular design, basically, so in May 2023, Lido V2 went live as a staking router right after Chapella upgrade. So what is staking router? It basically introduced a change that it is now possible to design and develop different modules that is possible to onboard like basic modules for many different kind of characteristics. So it is possible to allow a more diverse validator ecosystem. And yeah, okay, so soon after the launch of the staking router, 2 new modules were introduced. The first one is a simple DVT module, and then followed by community staking module. All right, so what is simple DVT mean? So DVT stands for distributed validator technology. You can kind of think it as like a multi-sig, but for validator. So you will work in a group, and basically it will be a threshold either like 3 out of 4, 5 out of 7, or 7 out of 10. And in the case for the simple DVT module, we are all a cluster of 7. So what is special here? So since you are working a group and you have 7 people, and everybody within the cluster, you are free to choose the clients you run, like different execution client, different consensus clients, and you can also have the infrastructure from different part of the world. So it makes like a single validator much more resilient in this way. So the module was initially launched with only 0.5% of the share limit, but based on the really strong performance we observed, later it is increased to 4%. So 4% sounds like not a lot, but if you like put to like numbers, it's slightly over 11,600 validators, or about 1.1% of the all Ethereum validators that's currently active running today. Yeah, so what is really, I think what is this module, the most important part from this module is it's due to the characteristic of the simple DVT technology, like much more community staker will be able to join the Lido protocol and run validators. Okay. Just a little bit numbers here. So the module was officially launched in February 2024, and overall it has attracted we have onboarded over 128 solo and community stakers. Okay, and then finally our last module, which is called a community staking module. It is the first permissionless module within Lido. And what are the key points for this community staking module? So the biggest change here is that instead of like onboarding practice, anybody can join this module. And what is also really cool is the design for this. They are very, the UI is very user-friendly, and there are also very easy integrations and online resources that really encourage anybody to join. So this module was at the beginning launched last year, October, with an early adoption phase, and it finally went fully permissionless in February this year. And so far, we have, there are over 300 independent node operators actually joined, and they are running over 5,800 validators. Okay, so, all right, just to show what, in order to see how the decentralization actually going, one of the easiest and way to see is just to see how many people are actually participating in the protocol. And so here is some numbers on 3 different modules. And so some people actually participated in more than 1 modules, as you can see here. Just a little note, like since community staking modules are completely permissionless, we are not able to like 100% sure if there are a SIBO there. So that's like, we try some algorithm and some research to try to make this number as close, as good as possible, but this is this. And another thing we can look at, and quite often being looked at, is what are the geographic distribution of all the validators. And so on the top image, it is the distribution for the curated module. What is really cool is that in one of the, I think on the 5th round of the onboarding, we really want to, because like all the validators most commonly are running either in USA or Germany, and there was really a lot less participation in Asia, also in South America. And that run, we managed to find some really cool node operators join, and they are running in Chile, Brazil, and Argentina. And then a second image is for simple DVT module. As you can see, there are more footprint in different parts of the world. I mean, if you just count the country, it's not, maybe it's still not super cool, but I mean, it's so good progress. And now, I don't have the status yet, but in Q1, we hope to publish a report maybe in April. And this is for the community staking module. We kindly ask if node operators are okay with it. They can submit information on how they run their infrastructure, so we can share all this information with the community. So that's all the modules we have now. And currently there are 2 more proposals and discussions on where we can go for now, continue in the future. Yeah, the first one is called the SSVLM, and it is basically a proposal for permissionless staking and for using SV networks DVT technology. So what is the difference between this one and the current simple DVT module? The difference is that, as I said, like in each cluster, you are running by a group of people. So you can imagine there's a lot of coordination that's needed. And in the current simple DVT module, all this complexity and coordination are still coordinated by someone. And in a simple DVT module, all this will be abstracted away by the module itself. And the second one, which is currently no proposal yet, but just like on the discussion of the features. So in order to further scale the community staking module, and also just to address some of the limitations, in V2, there is a concept that's introduced, I think it's pretty cool. It's basically to allow like a very specific way for node operators, so different operators, they can participate and kind of join in a specific way. So it's kind of gate sealed with like, and then for different operators, you can set different, like for example, reward share and this sort of parameters for them. Yeah, so that's basically my presentation today. And if you are interested in seeing how the Lido node operator set has been growing since the beginning, actually, you can go check the report. You can see all the information published since from 2021. And welcome to reach out if you have any question later. Thank you.
Thank you, Sabrina. Please get me whitelisted for the CSM V2. I have been waiting for 2 months already. Come on. Okay, so coming up next, we're going to dive into the dark forest of intent, having Porter's, having Ben Bangting Huang from Porter's giving a talk about beyond competition, what solvers do and what we see. Let's give a round of applause to Ben Bangting Huang.
Hello. Thanks, Ryan, for the introduction. And thanks, everyone, for coming to the talk. I'll be talking about what we have done in the past year. And I'm Huang Ting. You can feel free to call me Ben if you find it hard to pronounce, that's fine. I'm the CTO of Dingo, and we are doing some researches about being a solver and how to run in an intent ecosystem. So today's talk will be mainly about what our everyday attacks are and what we see in the future for intent. And this is our POAP. You can scan and claim the POAP. Yeah, and we have a series of activities, and we have a booth here, so make sure to reach out to us if you are interested in everything. Okay. So we are Portus, and our company name is Dingo, and we start up from building an exchange, and then we start to build DeFi's, like Fruit Combo, Protocol Link, start from 2018. But in the whole process, we found out the potential of what can intent solver system do in the future. So we started to run our solver on CalSwap in production since January 2024. And we already settled over $8.9 billion, executed over 2.8 million DEX swaps. And we are one of the first solver to support all the 4 chains on CalSwap. And now we have the highest settled batches in the past 30 days. It's continuously growing, but yeah, we are one of the most active player in the solver system. And besides the intent swap system, we also done some experiment with intent bridge system. But if you are interested in that, you can come to the booth and we can talk about it more. So what does solver exactly solves in this ecosystem, or what do we see as we think that it has more potential in the future? I think everyone is familiar with this name, which is liquidity fragmentation, because when we have different kinds of services, different kinds of assets, it makes tokens, it's not just tokens anymore. All kinds of liquidity have different kinds of way to match them that. So just like we start from building an exchange and continuing to DeFi's, the blockchain trading history is also changing. Just like when we have Ethereum, we have programmable contracts, then we have different kinds of decentralized exchange, which makes all kinds of assets start to grow. And by far, we have different kinds of liquidities to be integrated, and then we have aggregators to handle all kinds of complex executions. But we can do more. About the liquidity management models, some things we are familiar to is like order book, like AMMs, I believe everybody knows it. And another thing is like RFQs, which stands for request for quotes services. They are quote-driven and often run by some professional market makers. And they provide a very competitive price, but they are more restricted to be leveraged. So we can say that normal users cannot be accessed so directly. And what about other assets? They can be stored in protocol, they can be stored in Lido. So there are different ways to leverage these values when we need to solve other problems. So about the asset model suitability, every asset have different volatility and depth. So they have different models to use them. And also some major assets like ETH itself or like WBTC or some stable coins, they are also frequently being used by as a counterparty to most assets, which also separate their own values in different pools of DEXs. And the last one, specific use cases, just like when we are, I think the most frequent case is like LP tokens. Because when we store our tokens into a liquid pool, and then we can get LP tokens. Those LP tokens do have their own value, but they can be accessed in a different way. So that's something that we can say that if we have a better way to leverage them, then we can partially solve the problem of liquidity fragmentation. And the last one, so many chains, so many L2s. I think the L2s will just grow more and more. So that's something that every value can be placed in different places and not being solved naturally. Yeah. So all these fragmentation really blocks how the service can be developed and how users know how to use them and how they can manage their portfolio. And here comes the intent-based system. Aggregators do solve some problems to simplify the whole trading process, but they are centralized. And on the other hand, intent-based system, users just need to express their goals. They don't have to do the execution. We will do for them. And we are trying to be decentralized. Yeah, that will be done someday, but we are still working on it right now. So what exactly do solvers do for you, or what are we good at? So the first part is obvious that we have good quoting powers, and it comes from two different aspects. One is the diversity of liquidity integration. We need to support all kinds of liquidities and for all kinds of assets. Why? That's obvious, because everything needs to be in our toolbox to give better solution. And these kinds of liquidities doesn't mean that only DEXs, though they have different interfaces, they have different ways to use it. And we also leverage some RFQs and also some like protocols that involves different kind of functions. And we support over 80 protocols across 4 chains right now. And another thing is the liquidity utilization ability, which means the routing. We can optimize the routing based on the orders we are processing. We can separate the orders into several orders to find the best way for each one. And we can decide whether to execute this strategy or not based on the risk. And on the other hand, we can also combine orders, because for some RFQs, they require to have a minimum amount to give a better price. So in that case, we can combine the orders to build up the execution, and also we can have a better performance on how do we handle the gas efficiency. And also, since we do the execution instead of the users, so we can continuously optimize until the last second, till we actually settle the transaction on chain. So that's something we can do, but others might not. And since we do the execution instead of user, so users don't need to have their capital at first place. Let's say, as long as when we are executing the order, then they have the money on them, then this execution can be done. And another thing is that they don't need to handle with the gas fees. We will handle it for them. And the last one, I won't say it's the most important one, but it's more important than we have imagined at first place, is the risk management. Because the market always moves, right? So if you have experience on doing trades, you know that when you get a price, it doesn't mean that you will get the actual amount at the end. So this is something that solvers need to work on to mitigate the risk from market fluctuations, including the asset price and also the gas price at the same time. So let me trade for you. Okay, let's get a very simple example, like how to buy Pendle, just an example. When users want to buy a certain token, you can do some research and find the best price on the market, or you can go straight to the most familiar DEX you use. And then you take out your ETH and go to DEX and buy Pendle. That's a very normal process. But how do we do that? If you use intent system, you choose your own asset that you want to use, and then we will do the price discovery for you. And when we found the price, we can say that when you want to buy Pendle, you can swap your USDC to ETH and then ETH to Pendle. That's something you can do, but we will do it for you because we have lots of different kinds of liquidities to use. Like you can swap your USDC to ETH on Bebop, which is a close partner of us also, and use this RFQ to perform the swap, and then swap your ETH to Pendle on Balancer. And this ends up with a better price than you just go straight to some DEXs. So this is an actual settlement happens on Ethereum, which is handled by us. It's a buying order. But this case is really simple because there's only one order, right? So when it comes to a large amount of orders to be processed at the same time, the whole routing can be very complex. And this is something that we do every day. And hope that makes you think that we are better on this, okay? And the next one, after the quoting power, then we come to the risk part. Because I believe that if you use a DEX, you know what is slippage. It means that when you get the price, it doesn't mean that you get the amount at the final execution. And those slippage is caused by the market movements. And it may also cause some failed transaction if the amount exceeds the threshold you have settled. So these are the points that solver cares more than aggregators, because we are the one to do the execution. So when we propose a quote based on the order, then we guarantee to process the whole amount when the transaction is actually settled on the blockchain. So solver takes care of the risk. Solver takes care of the risk and cover the user's loss that caused by the market movements. And another thing is that since we do the execution, we have the ability to interact with some MVB services. So no more transaction failures will be caused by the slippage on the user's perspective. So if the transaction cannot be processed, then user's order will just return back to the order pool and then wait for the next round. It provides better user experience, and another thing more important is it provides a better system robustness. If the swapping system is integrated with by a product, then we can guarantee that your maybe a content system can actually process successfully instead of just reverting a transaction. Okay, so how is the risk model if it is so important? So we try to simplify the question since we have the slippage and also the failing transaction need to be handled. And we found out that slippage is really highly correlated to reverse. Although they have different reasons sometimes, but it's a strong positive. So we can try to solve the reverse transactions and try to monitor that instead of doing everything. And one of the reasons, obvious, it would be the price change, which causes the slippage. And another thing is the quote expiration. And the quote expiration is mainly being caused to some RFQ interaction to be failed, because RFQ often have their own restrictions that you need to settle your quotes within a certain time. Another reason are some smelly tokens. That's something we need to deal with case by case. It's annoying, but there's nothing we can do, just do it ourselves. Yeah. So after we know the reasons, so we are trying to decide some factors that can be modeled to solve the issue. And one of it is that I think we can agree that when the network is busier, it makes more possible to the price change. So gas price is something that we can monitor. Higher gas price means a busier network. And another thing is that with more interactions, when we are trying to do a better routing, it might have more interaction to different pools, but it also increases the risk that longer path and more hops will cause a higher risk of failure. Another thing is the order amount. If we process a lot of orders at the same time, maybe we can have better performance on gas efficiency, but it also increases the risk. And block settlement latency, that will be something that I just mentioned about the RFQ restrictions. And also, if we settle in a longer period of time, then the market state might be different from the beginning. And the last one, if we cannot think of any more that would be the root cause, we can consider on some results like revert monitor. We can monitor how our solvers doing right now. If a lot of solver is already reverting their transaction, then there might be some systematic problems right now. And token-based reverse. Token often reverse in a bunch together. So this will be something that we can consider if we need to do aggressive quoting or just more preserved quoting at the moment. And after being able to model these factors into our strategy, we can have a better reverse rate comparing to the market right now. So let solver take care of these for you. You don't have to concern about what kind of risk need to be managed. We can do all of this for you, including the asset selection, price discovery, the market fluctuation, and gas fees, and also the last part. Remember I said there are so many L2s, so many chains. All of these can be quite different on different chains. So these settlements can be decided by us. We'll handle it for you. Okay. So what will be the next step? After we have I hope it's robust system for every solvers to do the trades for users, we can start to think about how can we start off to give a unified experience across different chains, which means the cross-chain swaps. And this is a phrase that I like very much from the Open Intents framework, which is intents for everyone and with everyone, which means that everyone should be able to express their intents of what they want to do, and then other people that are being able to solve this problem, which is solver, know how to understand the thing that user wants. So it comes up with standardization and something else I will mention later. For the intent standardization, the intent stack is basically about the intent flow, which is how orders are being created and handled. Another thing is the settlement mechanism, is the order being processed into solutions and actually happens on chain. So ERC 7683 defines the interface about intent creation, execution, and settlement, which is a very good start and already being used in some intent bridges protocols. Another thing is the Open Intents framework pushed this even further. It proposed a modularized solver implementation and also the settlement smart contracts, which are two of the most important parts to settle all these things onto intent ecosystem. And besides the intent standardization, there's another thing about liquidity, because we solvers need to deal with all kinds of liquidity every day. And this will be a really redundant work between every solvers, including like every liquidity have their own strategies, design on indexing, encoding, and how to simulate every transaction if they will be successfully processed and what will be the state after processing this request. And there's another project named Tyco. They are a liquidity indexer. If you are interested in these kinds of questions about liquidity standardization, be sure you can take a look at this project. It's quite neat and yeah. So after the standardization, remember I just said, let's talk about later, it will be the collaboration. Because with everyone, for everyone means that we need to decentralize everything, and standardization is a very important part. But the next one is how do we actually have these much different roles, different solvers to do these works. So we need to collaborate instead of just competing with each other. The solver competition is quite straightforward to select the solution. And the consensus on intent system is basically about the solution selections, because we have all kinds of orders and we need to choose an answer to it. But the current selection method is mostly like one solver takes all. So every solver needs to be the toppest one. Instead of, you can still give some solutions, partial solutions, and then being combined together. And those competition is often driven by surplus maximization and first comes, first serve. So in this case, the challenge of current model will be that everyone needs to collect all the answers together instead of cooperating with other people. And this causes a lack of differentiation. And sometimes some solvers, they have their own liquidity source that cannot be accessed by others. Then in this case, if some of the order cannot be processed by these solvers, then these orders will be put aside and cause their execution to be delayed. This is also a problem that we need to solve in some cases. And combination of these two, we can see that scalability issues comes up. The solvers need to propose a very powerful single strategy instead of cooperating. So it's something we need to deal with in the future. So I believe that everyone sitting here believes in decentralized. Just like DEX's decentralized where the liquidity lives, solver will be the one to decentralize how the prices are formed, which are also critical for the value, where the values come from. And centralization initiates the scalability improvements, which makes the decentralization even possible. And also, there's another case that maybe we can, just like when I want to trade, I can go to aggregators and do the trading, but I can also go to DEXs instead of go to aggregators. And this standardization makes it possible to create a solver-to-table service, which means that services or users can go straight to the solver if they want. And this is something we're also working on, and if you are interested, be sure to come to the booth and let's talk. And the last one, it will be something that we need to think about is a new model of solution selections instead of just one solution each batch right now. The final goal is to incentivize the solver specialization, since that we need to have different diversity of solvers solving different problems. If we continuing expand our scenarios from a single chain to multiple chains to cross chains. So after we've done everything above, we are finally being able to solve the fragmentation of liquidity. Then it will be an important layer to support every protocol as the value layer. Okay, thank you for coming, and hope everyone enjoyed the talk, enjoy the event. And we are continuing to explore the future of crypto, and wish everyone have a good time. And the last one, we're hiring. So if you are interested in the topic I just mentioned, or you already have some thoughts, be sure to come to our booth. We have a series of activities to make you familiar with this, how everything works. And yeah, that'll be it. Thank you.
Okay, thank you, Bangting. Do we have any questions from the audience? Okay.
Hi, Ben.
Hi.
Just curious, if you solve intents from DEXs, how do you guys prevent from MEV? This is my first question. And the second one is, do you guys do hedge? until your liquidity being settled on the settlement network?
Yeah, good question. For the first one, how do we prevent from MEV? I assume there are two parts can mitigate the effect of MEV. One is that we use MEV service to settle our transactions on Ethereum. And when we do these transactions, we do them in batches. So if anyone wants to do the MEV like attacks on our solutions, they need to deal with multiple orders instead of just one. So that will make it more harder. But the main solution, I think, at the moment will be using an MEV service on Ethereum, yeah. And the second one, do we do hedge? We don't do hedge right now, because that's something that we need to preserve the value back to the user. So we're not doing currently.
Okay, thank you, Bangting, for bringing such an insightful presentation to us.
Thank you.
For the next talk, we have Alfred from ImToken talking about why ERC 4337 isn't that simple in layer 2. Let's give a round of applause to Alfred.
Okay. Hello everyone, I'm Alfred, and today I will give a talk about the issues of 437 on layer 2. And I currently work at ImToken Labs as a blockchain developer. And you can find more information about me in my personal website, chihaolu.me, and my Twitter handle is murmurlu. And here's the today's agenda. We have 4 target issues about the implementation of 437 on event-compatible layer 2s. And the first issue is authorization issues. I will introduce how to manage account in multi-chain. And next is the address issue. I will explain why the address is matters and why we shouldn't assume the address sent in 437. And next is the fee issues. I will introduce how to get rational pre-verification case on layer 2. And the final topic is contract accessibility. And before the target issues, I have a quick introduction for you to understand today's topic. So what causes the difference? We often subconsciously assume that implementation of 437 should be the same between the Ethereum and layer 2, but we may meet some problems like protocol difference and synchronization challenges. It will cause our implementation of 437 different. So for example, you may meet variations in EIP, RIP, hard forks, upcodes, gate structures, and fee mechanisms. And you may meet some synchronization problem like you cannot simply send one transaction and affect accounts across all chains simultaneously. But why we rarely discuss these issues before, it is because in the past, from the perspective of EOA, we share the same address and same private key between the event-compatible layer 2s and Ethereum. And even so, the asset is not synchronized, but the same address and same private key can make sure you use the identical authorization mechanism of your account. And now you have contract and AA accounts, not only the asset fragmentation, but your account address may differ and authorization methods will differ, and ownership states may differ too. Okay, the first topic is authorization issues. So if we want to change an account ownership on chain X, how do we ensure that chain Y updates as well? It means we usually want to call a transfer ownership function to modify our variable which perform as ownership storage in your country account. So what happens if it succeeds on one chain but not another? And this problem will occur in two scenarios too, like the changing signature verification. For example, you may want to change from passkey to multi-sig. And another scenario is if an user's control key is lost and you have a recovery mechanism in your country account, how to achieve the recovery across all chains. So our target question is there any protocol that can automate multi-chain authorization updates or make management easier? The first solution is multi-chain signing. In multi-chain signing, the user can sign a single usurpation once and broadcast it across multiple chains, instead of signing multiple usurpations to perform your authorization in multiple chains. So how to do the multi-chain signing? There are two approaches currently. The one is Coinbase's approach. It ignores the chain ID field from your usurpation hash. So in your country account, in the signature verification phase, the signature doesn't include chain ID, means it won't verify your chain ID from a signature. And another approach is zero-day Merkle tree. It combines multiple usurpation hash values from different chains into a single Merkle root. It means the user only need to sign a single Merkle root to perform their authorization for the multiple usurpation in different chains. So your signature will, your usurpation hash will in the Merkle tree's leaves. And they, both methods all share a common trait. They bypass the chain ID restriction during signature verification. The Coinbase's approach ignores chain ID field in the usurpation hash, and zero-day's approach includes all possible chain IDs within the Merkle tree. And another solution is wallet provider support. If you are using a web-based wallet, you need a database to check the user's current authentication method chain because the web author need to record the domain and device. And if you have web author validator in chain A and ECDSA validator in chain B, you may need this database to record your validator. And another example is if you only have ECDSA validator but you have different ownership, aka public key in different chains, you also need a database to record it. So the database can ensure a seamless and secure user experience. And wallets can also provide an alert or a one-click sync function to unify the authorization methods across all chains, and it can help your user, it can notice user what they should do. And next issues is address issues. So why address is issues? It is because from an EOA perspective, users expect their account address to be the same. So if they doesn't have this in their mindset, they will unknowingly send funds to a recipient they don't have control, and it will lead to asset risk. And some bridges assume the same address between the two nodes. So if your user doesn't double check the recipient address, it will also cause the asset risk. And when your user register their ENS name, they should double check the registering address too. So the address difference is primarily caused by the protocol difference, like whether a layer 2 follows layer 1 hard forks in a timely manner and whether a layer 2 supports all layer 1 precompiled contract and EIP. And not only the layer 2 cause difference, but the layer 1 may doesn't support some layer 2 exclusive features like zkSync uses a different encoding method for country creation opcodes, and Ethereum mainnet doesn't support certain RIP. But why wasn't this an issue before? It is because in the past, like the merge, it only affects a little subset of your current smart contract, but the newer opcodes like push 0, which is introduced by Shanghai hard fork, will almost affect every contract in the Ethereum. And the ERC-437 also amplify the importance of consistent address. Next, I will introduce some past and future hard fork impacts. The first one is Shanghai hard fork, which introduced push 0, and certain chains and tools initially didn't support these opcodes. So if you want to prevent producing the push 0, you should specify the event version and solidity compiler version to maintain the identical address, even your solidity high-level code is identical. And Cancun also introduced new opcodes, but it's not affect as significant as push 0 because currently the solidity compiler doesn't allow transient storage as your data storage. With the high-level solidity code, you should use the tstore and tload opcodes with inline assembly. And in the future, once EOF goes live, we will likely encounter similar issues. And so how to make sure the address identical, or how to solve the address issue? The simplest way is fix both the event version and solidity version when you compile your code. For push 0, you can specify the 0.8.19 as your event compiler version and specify the Paris as your event version, and this can prevent the push 0 producing. And you may need some tool like event diff to help you know the difference between layer 2 and mainnet. But the number of decision-making criteria will only grow over time because we will only have more and more hard forks and more new opcodes. So the long-term solution is do not assume that an account will have the same address across all chains. This should be a fundamental mindset shift, and you may you may notice your user, or you can help them to use the ENS, and it can enhance a lot of user experience. And next issues is fee issues for the wallet provider, like I'm token. Calculating pre-verification gas in 437 is a hard issue because in layer 2, the pre-verification gas includes layer 1 cost and layer 2 cost. And before I introduce how to get a rational PVG from the perspective of layer 2, let's recap the PVG first. So in 437, the bundler sends user operation to an entry point by calling the handle ups function on the entry point contract, and it is a regular transaction, and we call it bundle transaction, and it is a superset of the verification phase and execution phase. So there are some gas costs isn't included by the verification gas limit and code gas limit, but this gas cost should be paid by the bundler, and bundler charge user your account contract with the PVG field. So you can see the 10-day gas profile for the handle ups function. You can see the validate prepayment is verification phase, and execute user up means your execution phase. And there are some gas cost isn't included by the verification phase and execution phase. So you need to specify the PVG field to pay this cost to the bundler. So the PVG means the gas cost cannot be checked via changes in gas left on chain. And PVG includes the following two parts. The first part is the cost of processing and user operation in the entry point contract, like 21,000 Stephen and memory usage and copy. And the memory usage cost means if you have more code data in your bundle transaction, you need to pay more gas cost for the memory expansion and intrinsic gas. And another part of PVG is additional expense. You may pay the subsidy for prioritizing the bundling of the user operation from the main pool, which means you pay more to let the bundler pick your user operation from the main pool quickly. And a fee for bundlers to prioritize their bundle transaction with the block builder. And on layer 2, you must account for layer 1 security fee. And this is what we talk about today. So how to get rational PVG on layer 2? The total cost for bundle transaction is equal to layer 1 cost plus layer 2 cost. Layer 1 cost means this bundle transaction security cost from the perspective of layer 1, and layer 2 cost means the processing cost of this bundle transaction on layer 2. And then we can do some math. We express the total cost for bundle transaction equals to gas price multiple total gas used. And this gas price refers to the gas price on layer 2. And then we divide by gas price, we can get the formula total gas used equals to layer 1 cost divided by layer 2 gas price plus layer 2 cost divided by layer 2 gas price. So it means what we need to pay from the perspective of layer 2. And then we can define the layer 1 cost as layer 1 core data cost divided by layer 2 gas price. And from a layer 2 perspective, we can get the how much layer 1 security fee need to pay with the layer 2 gas price. We can get the formula layer 1 gas price multiple layer 1 core data size divided by layer 2 gas price. Okay, math lecture. And the total PVG on layer 2 is composed of two parts, the PVG for layer 1 and PVG for layer 2. So we have already get the PVG for layer 1 because PVG for layer 1 equals to layer 1 security fee equals to layer 1 core data price multiple layer 1 core data size divided by layer 2 gas price. And this formula calculation can help us get the rational PVG from the perspective of layer 2. And it is a complex calculation. So in long term, you can try the RIP 7560 to simplify the calculation. It defines the cross-raw native AS standard and replace the PVG field with builder fee. And the builder fee means the layer 1 data fee. And the intrinsic portion of PVG is set as the constant AA-based gas cost. So this RIP can help you simplify the PVG calculation of on even compatible layer 2s. But in short term, or you want to make your product more stable and you want the optimal earning, you may set up your own bundler or establish a business partnership with bundlers because the PVG calculation is complex. You may charge an unreasonable gas fees. So set up your own bundler is a better choice. And the final topic is contract accessibility. The first one is infra accessibility. We assume the event compatible layer 2 should support all of Ethereum precompilers, but some like Scroll may not fully support due to circuit limitations. And you may, if you are using A accounts, you may want to use the SCCP 256R1 signature verification in your contract account. So you may try the Dymos implementation or RIP 7212 to verify your P256 signature. And if you are using the R1 signature verification, you should check your verifier contract is accessible in your target contract, in your target chains. And next is the service accessibility. Choosing bundler and paymaster is a hard question for 437 developers. There is a very embarrassing problem is many services depends on nodes such as your bundler, paymaster, and relayers. And before they actually send the transaction or return some results to you, they will do the simulation. And let's take the 7212 as an example here. If the service you are using doesn't use the latest node, it will cause problems in simulation phase. For example, the optimism supports the RIP 7212 in 2024 Q3, and Alchemy Bundler is expected to support the P256 precompile by 2025 Q2. So if you are using R1 as your signature verification mechanism, and you send your user operation to the Alchemy Bundler within this period, your user operation will fail due to the simulation fail. And it may not affect your contract logic. It won't let your account stolen, but it will affect your product stable because users have a valid signature, but their user operation cannot be sent. And next is tool accessibility. We usually use development frameworks and tools like Foundry Creative Factory Contract, multi-core free contract, Slither, and we need to check if they support the new hard fork or not. And it is because there is always a period of transition before and after a hard fork. So if you do the important operations like deploying contracts, launching products, or upgrading contracts in this period, it is very risky and inconvenient. Okay, the conclusion. Today we cover some issues like account synchronization, authorization mechanisms, address consistency, and PVG calculations on layer 2. And here are some key takeaways for you. If you want to manage the cross-chain accounts, you can try the multi-chain signing to help your user sign only once to send it broadcast to multiple chains. And you may rely on wallet provider support to help you enhance the user experience and achieve the security. And address at divergence is unavailable but manageable. You should not assume the address same. And you may try you can try the ENS. And PVG calculation on layer 2 is more complex than expected. And in long term, you can use the 7560 to simplify your PVG calculation. But to make your product more stable, you should set up your own bundler or establish a business partnership with them. And in the future, the 487 on layer 2 will depend on how infrastructure providers, wallet developers, and rollout teams collaborate to make it a true standard. Thanks.
Thank you, Alfred. Do we have any questions from the audience? Okay, I have one. I'm curious about, is 4337 your interest, or why do you study 4337 so hard?
Okay, because we are developing our web app, a new cutting-edge wallet which use the 437, and today's I share the issues about how we meet on layer 2, and if you want to know more about tokens wallet, you can go to building A to listen Nick's talk in 2:30. Yep. Our next talk.
Okay. Then thank you, Alfred, for giving such a good talk on ERC 4337. The next panel on privacy community, we will start in a bit, but there's a couple notices that I want to bring up first. So the next talk won't be live streamed or recorded. So we prefer the audience also do the same thing to remain the privacy for the panelists. And we'll give you a heads up before the next panel started. So feel free to grab a drink and take a break.
Hey everyone, welcome back. I'm Teresa and I will be your host for this session. We've got 3 awesome talkings coming up. And first, we've got Phoenix from Tea House Finance. Phoenix is here to share how Tea House is building a leveraged DEX, and that helps manage liquidity with minimal price exposure. Let's welcome Phoenix.
Wait. Hi everyone, my name is Phoenix. I'm the CEO of Tea House. Yes, right there. I feel honored to be here and to be put together with all this awesome crypto brands and protocols right there. I just got back from Ethereum Denver, and I'm still jet lagging. So most of this talk will be talking about what are the products we're building, and some of the language used will be part English, 然后一点中文，因为我讲中文比较好笑。对。So without further ado, let's just start it. So first of all, I'm really thankful that you guys are here to listen to my small talk because this is the most weird title on the agenda today. Is a leverage DEX. The other people got like the path to the future, the cross-chain interoperability, something like that, and mine is a leverage DEX. So it's really boring. So yeah. So let's go into talk about it. And I didn't do the deck, and so you guys have to bear with me and let's go ahead and start it. So this is my small notes. The title should be T-Rex, a leverage DEX built on top of the liquidity pair. T as Tea House, Rex, the dinosaur, as the reactive liquidity DEX, something like this. And what we're building is a spot leverage DEX. It's a counterpart of the Hyperliquid or Uniswap or the other perpetual product. So Tea House Finance, if you guys know, we started by doing a strategy on top of the Uniswap v3. Because when Uniswap v3 come out, I think it's a Red Bull. Yeah. When Uniswap v3 come out, so you can set a liquidity range between each liquidity pair. And we realized that the ordinary user cannot actually perform well on a liquidity pair. So there has to be a professional strategy layer on top of the Uniswap v3, so you can be able to make money from providing liquidity. Because most of them will be screwed by the IL, impermanent loss, right? Anybody know what IL means is? Oh, yeah, of course you do. 朱CC over there. Yeah. And we got crushed by IL too. Because like we tried a lot of stuff. Like you can constantly rebalance your position and your IL become realized lost. It's not impermanent, it's permanent lost. And once you rebalance that more, you got a lot of like costs, fee costs. You got a lot of like position deduction. You got a lot of shit going on. So we realized that if you want to provide liquidity with a profit, you have to find a way to actually hedge somewhere else, not on the Uniswap v3. So we'll keep looking for other solutions. We try to talk with the Binance, all of the centralized exchange. We try to go with other perp DAX. But we realized the overhead is actually too big. So we realized that, I use a lot of realize. 所以我发现我必须要想办法自己盖一个 product. 所以我们做了一个 so we built a product, Tea House, T-Rex, which is the Tea House Relative DEX, which is a spot exchange. So we want to discuss the relationship between the liquidity pair and the DEX. What does that mean? Usually,
the liquidity pair on the Uniswap v3 provide the price to a perpetual product. So what's the relationship with them? First, there's no relationship. You have a price oracle, and you build a perpetual DEX. So all your price is coming from link, from path. You don't need Uniswap v3. You build a standalone casino for your user. You're not actually in the ecosystem, but you make money. That's great. And the other thing is, the other relationship is you use a price from the liquidity pair, which is a price discovery. And you use that price as your perpetual product, like Hyperliquid and GOP. But what happens recently is kind of like, you realize that when a small cap token can actually scoop out all your work by manipulate the spot price. Anybody know what happened in the hyperliquidity these days? 有人知道发生什么事吗? Okay, so, yeah, exactly. So basically, the merit of the Uniswap is like when you want to list a token, you can just create a liquidity pair and you list a token. Anybody here want to list a token through Binance? It shouldn't be here. It shouldn't be in token 2049, right? Yeah. So once you do that, there's a price on the Uniswap v3. Then your perpetual DEX, you're just using that price to fit into your perpetual product. So what happens in hyperliquidity is somebody short the perpetual product on hyperliquidity and buy the spot on the liquidity pair. So actually, 其实就是让 hyperliquidity 遭受损失. So what do we do to prevent that problem? Actually, you cannot. You can, overall, eventually they solve it by the centralized solution. You just use the price oracle and trace back the other trade. And everybody take a loss because you can't beat the house. I think that's the merit here. The merit is you cannot beat the house. If you beat the house and there's no game and there's no trade, then eventually all the DeFi collapse. But this is what we become. Do we want to become a standalone casino, just a house and acquiring player to play and we win their money and to sell GOP or HLP? Can we build another solution, try to solve the impossible triangle these days? There's a new impossible triangle in the DeFi strategies, in the DeFi DEX right now. Is A, you have the leverage, the huge leverage. What kind of leverage a trader can go to? Like, 就是多少杠杆它可以开？它可以开100倍吗？它可以开几倍？ That's your one asset of your triangle. B is the profitability of your staker, your lender, your GOP or HLP holder. And C is the safety of your protocol. Like, eventually you realize that you cannot actually to have these three conditions all align with your alignment. 如果你想要开很多杠杆，然后你又要你的 HLP 赚钱，谁负责扛这个损失？是不是就是 protocol？ 如果你的 protocol 想要安全，你的 HLP 的使用者想要赚钱，你势必就不能让他开那么多杠杆。如果反之亦然，如果你另外一个角度去看这件事情的话，你就会发现这个三角形是不太能够被满足的。只有一个方向能够满足这个问题，就是等一下会讲为什么。但是我们现在讲的是 ，So how do we do about this triangle? Can we just compromise it a little bit to make a new product? That's what Tea House is doing. Because what's the ultimate goal of a DeFi goal here? What's the ultimate goal of DeFi goal here is for every liquidity pair, there's a multiple liquidity pair of say Ethereum and USDC. And you got the price from multiple of them. And you probably take out the top one and the bottom one, and you generate your own price oracle from this multiple liquidity pair into your DEX product. That's kind of the most DeFi solution to this kind of question. Otherwise, you're gonna use a centralized oracle, right? Because you never know the so-called decentralized oracle, what their prices are generating from. They may be from the same origins, you never know. So in order to do that you use the multiple liquidity pair price to become your price oracle. And you cannot, because the liquidity on those pair is not that many for meme token. So you cannot require to let your trader trade like 10x, 100x of that token. Probably just do like 5x, or even 3x. So what do we do it? We actually book the protocol called T-Rex, and we help when the player want to trade, say 10x the BTC, the trader deposit $100 into our protocol, we actually lend $900 to it. And they become $1,000. And we buy spot WBTC, and we keep it there. So if the BTC price go up, the profit can go to infinity. There's no counterparty risk over there. So if the price goes down, we want to know if the price is gonna, if it hit the $100 this deposit, maybe like we can say $90, $80, whatever, we go through a liquidation process. So that's basically our protocol. So what's the marine of this protocol is actually it's like a Lego piece. You build on top of a swap, and you build on top of a lending protocol, and you help facilitate the entire blockchain transactions there. You're not a standalone casino. Because most of the time, the swap has an incentive, and the lending protocol has an incentive. So they actually help user to trade on your leverage DEX. That's our product. It's actually live today on SEI. Which is a L1, SEI. There's a booth over there. People can try to open up a position and close it up. Once you do that, you get a little present from T-House Protocol. Yeah. 我再用中文讲一次，就是它就是一个很简单的 SPA leverage 的 DEX， 但是它实际上能够执行所谓的 blockchain transaction， 就这个交易是真实存在的。它并不是只是卖你一个金融商品，而是这个实际上就有人持有那个10倍的 BTC 的现货就在那里，然后看它价钱涨还是跌。所以，那 staker 提供这个900块的人赚什么？就是赚利息跟开仓关仓的费用。所以变成说是它并没有 liquidation 的问题，应该说问题比较少啦，不会那么夸张。那这样子的产品，我们认为在这个 DeFi 空间里面会更去中心化，并且我不敢说更有竞争力。I wouldn't say this product is more competitive, but it's more blended into the most ecosystem because all the EVM and all the L1 has its own swap and has its own lending protocol. So you build a Lego piece on top of it, then you start from there. That's basically what we do. And so why does T-House Finance start building this? Because eventually, if you think about what user wants, all the traders wants to 100x something, right? Or 100x long, 100x short something. But they don't need a Uniswap. Uniswap cannot provide this feature for them. 你用 Uniswap 就 swap 嘛，没办法 long 或 short 多少 x 嘛，对啊。But the other thing is, why do Uniswap still exist? Is if you are a protocol and you're issuing a token, you have to provide a liquidity pair. And you have to provide a way your user can 10x long or 10x short your token. That's why you need this. So eventually, T-House realized that ordinary users do not use the Uniswap or liquidity pair, provide liquidity to the liquidity pair anymore. Like, if I ask you a question, Who here is excited about there's a liquidity pair APR is 1000%？ 有没有人看到一个 Uniswap 上面的 pair 叫你提供流动性，告诉你说它的 APR 是1000% 的人会感到兴奋的？没有。Why isn't that? Because we all know the IL will kill you, and we all know it's not gonna last. But why is it Uniswap still exists? Because it provides a way to actually create you guys, to list you guys' token. And once you list it on Uniswap, you still need to find a way to let your user 10x or long or 10x short your product. Because volatility gives your token life and gives you free and gives you the actual liquidity provision, the fees. So go back to T-House, that was the DEX. So we are actually creating a strategy to become a more delta neutral for liquidity provision. Yeah, so I actually have some pictures. Yeah. So remember why we're doing this. We're doing this for the protocol. Because user, you can just trade it everywhere, right? So we're doing this for the protocol. So we're actually providing a strategy. We can use the DEX to make the liquidity provision on the liquidity pair more delta neutral. And this is our result. 你看我有些小抄，然后小抄都写得很烂，对。And this is our result. The result is really promising. And hence we build a lot. So we want to create a world where when you guys have a token, there's a delta neutral strategy to let people provide liquidity into your token's pair. That's gonna create a protocol's life. It's a lifeline of your protocol. Because for every protocol coming to T-House and ask us about how to do market making on DeFi, they only want to do one thing: how to sell our token quietly and gradually without impacting the price. And the answer is, you have to have enough liquidity over there. And how do you have enough liquidity over there? When you provide liquidity into it, there has to be delta neutral. Otherwise, people will just get killed by IL. No matter how much bonus token you give, no matter how much 1000% APRs over there, people still getting killed. So that's why we developed this strategy. Eventually, all go back to how do we grow the entire Uniswap V3 and how a DeFi system back when people are willing to provide liquidity into a liquidity pair. I bet right now, no one is doing this. 这里现在有人放钱在 liquidity pair 里面吗？不可能嘛，对吧？没有嘛，是吧？ But we find a way, and we really want to do it to make it work. So the final strategy. So results, there's a mean reversion strategy based on the delta neutral strategy. The mean reversion is basically, we believe something like the altcoin season is gonna come, if you think that way. So the result is like, we use 10K, and we kind of made 33K something. Our APR is 53%, and it actually works. And we can actually do the dynamic things. Is like, we can actually accommodate when the protocol want to sell their token. Pretty much is like, you use a delta neutral strategy plus a damping in your equation, because the protocol want to sell on top of it, right? Then you become it's a new way to actually do the liquidity management. Yeah, that's basically what T-House is doing. But there's actually another way to solve that impossible triangle I talked before. It's called order book. 所以其实听起来蛮糟的，就是我现在看到的事情是，我觉得 order book 感觉要起来嘞，干。Because then you don't have that kind of problem anymore, right? So I feel like if you want to solve this problem, eventually you will see the order book coming back. Because I think right now the blockchain capability, you don't need the gas fee on top, on the on four, and you kind of need you can actually build an AI agent to help your user to sell their token on the order book, right? Like, help me sell this token 10% before above the market price within this 24 hours. You can actually build a lot of AI agents on top of it. And it's easier to do it with the order book way. But like I said, right now, we're still focusing on how to make DeFi greater, which is you have to build the Lego pieces on top of each established layer ones, layer twos, and established protocols to become one of them. And eventually, we will together make DeFi actually meaningful. There's 5 million left. I want to talk about my trip from the Ethereum Denver. Anybody here go to Ethereum Denver this year? How was it? Not really good, right? Yeah, that's what people are saying. People take out their trading app and they think the Ethereum is going down. I don't believe so. I believe most innovative thing and most things gonna take off is going to happen on Ethereum. That's why I still believe. T-House Finance has been working on Ethereum EVM for like 4 years. We're still here. So we believe like eventually everything will take off and the Wi-Fi password will actually make sense to everyone. Yeah, okay. So we really hope next year Ethereum Denver will be really good and follow up the Ethereum. There's not gonna be another Ethereum Taipei? I don't think so, right? But Ethereum in Asia will be really good too. Thanks, everyone. 其实我真的不知道自己在讲什么，谢谢大家，谢谢大家的时间。
Thanks, Phoenix. Super cool to see how T-House is thinking about DEXs from ecosystems angle. Next, let's welcome Zen from Automata. Zen is going to talk about how we can actually verify that an AI agent is autonomous, how it makes decisions, and how to make sure no one's secretly pulling the strings behind the scenes. Welcome, Zen.
Hello. Oops.
Let's hold on for a second. We have some technical issue.
Hello. Okay, I think they're still kind of like sorting out the slides and like as usual, technical issues. So anyway, I'm really glad to be here. My name is Zheng Leong. I'm one of the co-founders of Automata Network. So I have to kind of like fill in the gap while the slides are coming out. So today I'll kind of like be sharing a little bit on like AI agents, AI in general, what is a model, what is an agent, how can trusted execution environments, TEs, be used to help us establish kind of like trustworthiness, trust with the models and services that we are using. So to kind of like get a sense, how many of us here in the audience actually you have heard of what a trusted execution environment is? Oh, not a lot. So maybe I'll kind of like, while they are trying to do it, I'll give a brief kind of like description of what a TE is. So I like to give the analogy of a trusted execution environment as this like magic box. So you have this magic box, there's a fairy that lives inside this magic box. So what can this magic box do? This magic box actually, it has a very powerful magical shield that would prevent people from actually looking into the box and figuring out what is happening within the box. The fairy inside this magical box would actually kind of like, it would perform exactly the instructions that you ask this fairy to do. So for example, let's say, today I like to bake some blueberry cupcakes. So I have this secret recipe that I don't want to tell anyone. So I'll take this secret recipe, write it down, put it into the box, and put in all the ingredients that I need for my blueberry cupcake. My blueberries, flour, egg, milk, so on and so forth. Put it into the box, close it up. No one can see that secret instruction that I gave. My secret recipe remains in the box. The fairy would actually follow my instruction step by step, word for word, letter for letter. And the end result is I actually produce this blueberry cupcake. So what a trusted execution environment gives us is really like two main things: confidentiality and integrity. So it enables us to be to have confidence over the kind of like integrity of the computation that is being performed within this trusted execution environment, and it helps protect the data that is being used within this environment. So I see that the slides are up. So let's get into the kind of like presentation proper. Okay, so first, I think like probably like since 2 years ago when ChatGPT was first kind of like announced and launched, we have this sense of what an LLM is, large language model is. It's basically a model in which we can interact with the model, we can ask the model questions, and the model would kind of like give us the answer to our question. So the question really is, what is the difference between this AI model and an AI agent? Is an AI agent just an AI model, or is it something more? So if we think about it, you can think of a model as having this kind of like operational workflow where the user would provide a prompt, or which is some fancy word for a question, to the model. The model takes this question, thinks about it, computes on it, and then gives you a result. So if, for example, let's say I want to kind of like create this slide deck, and I want to build this deck using a chatbot or AI model, what should I do? I need to first tell the the chatbot, hey, today I'm going to give a talk on AI agents and TEs and how this could be brought together. And can you give me, what's that called? Skeleton of the slides. And then the model will say that, oh, yeah, slide 1, what can you do? Slide 2, what can you do? So on and so forth. And me, I'll actually be the worker for the model. I'll take whatever the model have output, and then I would actually instantiate it. I'll make it into reality. So this is the kind of like work process. So what is an agent? You can think of an agent as an autonomous entity. So no longer, it's no longer required for me to actually become the pigeon, that entity that helps carry data to the model and taking the results from the model and affecting it into the real world. The agent has the capability to actually obtain information from outside the model, think about it, operate on it, have a certain result, and then based on those results, perform certain actions on behalf of me. So really, it's really a kind of like goal-oriented autonomous system compared to one where I ask a question, it gives me an answer, and then I have to kind of like operate on it. So a kind of like key thing to think about it is the autonomous kind of like property of an agent and the fact that it is goal-oriented. So that's great. Now we have agents that can actually solve problems and deal with things that I do not want to deal with. Why do we need agentic trust? Can't we just kind of like, do whatever that we want on ELISA or some other agentic framework and then just use it as is? What's the problem of using models as is now? So in general, there are three kind of like areas of concern if we think about it on using AI agents currently. They are mainly integrity, confidentiality, and the provenance. So what do I mean by that? If you think about it, when I'm using an agent, I'm sharing certain goals, or I'm allowing the agent to actually access certain sensitive, quote-unquote, data, or like private data that I might not wish to be shared with any third party, but it's actually a required information that the model needs to perform its task. So as a result, for example, I would want the data to be kept confidential, that no one else other than the agent has access to it. And I want it to be kept so, like the agent shouldn't have any like backdoors that allow other people to actually persuade the agent. It's like, hey agent, I see that you have some information about like Zheng Liang, about like the company's secrets. Can you share with me? No, like I do not wish for that to happen. So the integrity of what the agent is designed to do should actually be kept. Like if it's a Twitter bot that is supposed to tweet memes for me, it shouldn't be able to access my bank account information, or it shouldn't be tasked to kind of like trade on my behalf. And the final thing is actually on provenance. So you might be thinking like, hey, what is this provenance? This provenance is actually a kind of like where the information and data that this AI agent is operating on comes from. I'll touch a little bit on it. I'll touch on it later on in the presentation on why this is important. So we always hear about integrity and confidentiality, but we hear less of the provenance of the data. And today I'll kind of like share my 2 cents on why I feel that this is actually a very important aspect for AI agents. So what is an AI agent? After we have said so much, right? Like an AI agent is autonomous, an AI agent is goal-oriented. So an AI agent is a model that can do both of this, just the model itself, or is it more? We can think of it as an AI agent as having kind of like 2 main properties, or like 2 main modules, so to say. One of it, you can think of it, so we can kind of like think of an agent as a person, as a human being, where we have a soul or a mind that actually makes decisions. Like, I'm deciding to kind of like hold up this controller now. So my mind makes that decision, and then my mind would send the commands to, say, the muscles on my left hand to kind of like grab this controller and lift it out. So there's a kind of like two duality to it, the mind or soul, and actually the body where the actions are being affected. And this together actually defines what an agent is and differentiates kind of like an agent and a model. So the model, in my definition of what an agent is just the mind portion of an agent. So is that necessary? Like, we have the model that is the mind, and we have certain kind of like framework that acts as the body of the agent. Therefore, this is an AI agent. Not really, right? Like, I can run, say, an OpenAI, say, ChatGPT 4.0 model with Eliza OS as the action framework. Now, if this is the kind of like combination that I use, and you use the same combination, are both of us running the same agent, or are the agents different? If the agents are different, what is the difference between the agent? There's actually a third portion to it other than the model, the action framework. And the third portion really is the parameter or the context, the memory of the model. And that differentiates one agent from another. Both of us, we can use the same model, we can use the same framework, but if the context that we are using, for example, the historical interactions that I have with my agent is different from the interactions that you have with your agent, then that, in essence, is what separates my agent from your agent. And therefore, it forms the context or memory forms an important aspect of the identity of the agent. And this would be important when we are talking about like, how do we go about verifying the trustworthiness of an AI agent? So with kind of like all the definitions set out, we have the kind of like mind-body duality, we have the model being the decision maker, we have the action frameworks or the agentic frameworks being the kind of like body or the module that affects the real world, and then we have the context that acts as a form of a memory, the experiences that an agent have. How can we go about kind of like, do we have a framework in the way that we can grade or evaluate the trustworthiness of this AI agent? So here I'm going to introduce this notion of these 5 levels of agentic trust. And how we can actually use this framework to kind of like see where we are in the entire hierarchy of trustworthy AI agents. So we'll start off with the first level, opaque AI agents. So this is basically what we have with what we have now. Like there's no way for me to verify what an agent used. The agent can the service provider or the agent can claim that they are using DeepSeek, or they are using Llama, or they are using ChatGPT. I can claim that I'm using what's it called? An IM token wallet, or I can claim that I am using a particular Twitter bot. There is no way for me to verify anything, and I can just, I mean, the only way that I can do it is I trust what the service provider or the agentic, the AI agent provider tells me. It's a kind of like trust me bro kind of like situation, which is a very bad situation to be in, and we don't want to be stuck here. So what is the kind of like next level of it? With level 2, we call it like verifiable AI agents. What we are introducing on the second level is really the ability for us to verify certain aspect of the AI agent or components of the AI agent. So some of the techniques that we can use here are things like trusted execution environments, or even like purely cryptographic primitives like ZKML. So for example, in certain situations, if the model is small enough, I can actually make use of ZKML to prove or to allow you to verify that I am indeed using the output that comes from a particular model. So if I claim that I'm using, say, 80,000 parameter model, I can make use of like ZKML, or say 1 billion parameter model, I can make use of ZKML to provide a proof that, hey, I'm indeed using this particular model with this particular set of weights. And what a trusted execution environment allows me to do is something similar. I can give you a cryptographic proof. It's actually a cryptographic attestation on the type of models and the weights and the environment that this model is being evaluated on. And this sort of primitives allow us to at least have the capability to verify that the output of this or the component of the model is indeed what it says it is. So with that, how can we make it even better? That's where level 3 comes into play, where now that we have the ability to kind of like verify certain claims that the module have, the next step really is to kind of like associate this claim to, associate the model or the component that is being executed to what it claims to be. So for example, I can say that, hey, I'm running a particular model. I claim that this model is a DeepSeek 70 billion parameter model. I can give you the hash, and now the question is, I can verify that this is an attestation, but how do I know that the attestation that you give me is indeed one of DeepSeek's 70 billion model? So I have to have a way to actually like draw this connection from the actual claim that I have to verifying the claim with respect to the AI agent instance that is being run. So this can be done in several ways. One of the kind of like ways is something called reproducible builds, where let's say I have the source code of one of the components, maybe the Discord module that allows the AI model to actually perform its chat functionality within a Discord channel. Now, the thing is, how do I know that that program or that binary that's running within the environment that my AI agent is using is indeed that particular Discord, Discord module, so to say, and there isn't any backdoors that is involved in it? I can open source my Discord module on GitHub. Any user that wants to establish this fact can go and download or like clone my GitHub repo and then perform a build on their own system with it. And they can, after performing the build, they can kind of like get the actual binary that is produced, and this binary should actually match up with the binary that is being used by the by the AI agent. And this way, I know that, okay, the AI agent claims that it's using binary X. I take the source code of the Discord module, I compile it myself, and it produces X. Therefore, the AI agent is indeed using the particular Discord module that I know has no backdoor in it. So this is what like reproducible build actually does. So it's a bit cumbersome, right? I think most of us don't really want to like download all the different modules that we use and then compile it ourselves, or have to figure out how to compile it ourselves, get the binary or the hash of the binary and then perform the comparison ourselves. Are there any other ways about it? What about in cases where the source code is actually not open source, it's actually closed source? How can we actually tackle this? So here, I kind of like introduce this idea of what we call a testable build. You can think of it as a kind of like a trusted delegation. So instead of me having to do this reproducible build myself, I can delegate it to a trusted third party. This trusted third party can be a PE itself. This trusted third party can actually be a kind of like group or council. I mean, in the ZK world, we have all the trusted ceremonies, right? Where a whole bunch of us would come together to contribute randomness or entropy to generate, say, a shared secret. In this case, we can actually have some sort of build ceremony where a whole group of us come together, clone the GitHub repo, build it on our own system, and then contribute in a kind of like open, decentralized manner that this is the hash, or this is the binary that I get. And then through the consensus process, establish that indeed the, what's it called, the GitHub repo source code corresponds to a particular binary that is produced. And if you think about it, if we kind of like push that idea one step forward for closed source projects, this council, instead of everyone, can actually be a smaller subset of kind of like trusted auditors where they have access to the closed source software and can make attestation on behalf of the project owner. So with that, we kind of like complete that link between the AI agent, the components used in the AI agent, with us being able to verify it to a specific kind of like claim or source. Now, with this kind of, with this at level 3, we have actually established the trustworthiness, the integrity of the AI agent. So that's it, right? Like, if I have an AI agent that I can verify computes exactly what I want it to do, then everything is okay. It's actually not the case, because if you think about it, at level 3, we actually have a kind of like a trusted core, which is the verified AI agent. But decisions that are made by the AI agent is actually affected by the data that the AI agent obtains. So for example, I might ask the AI agent to help me manage, say, my ETH portfolio. And then I tell the AI agent to, you know, if ETH is below $1,800, please sell all my ETH. If the data source that my AI agent is actually obtaining the ETH price from is malicious, and like instead of the price of ETH being 2,000, it says that the price of ETH is 900, then the AI agent is going to make a decision based on an incorrect, or even worse still, malicious data that is provided to the agent. Therefore, I mean, it's something what we call rubbish in, rubbish out, right? If you base your decision on wrong data, then your decision itself is going to be wrong, even if whatever that makes the decision is correct. As such, what we need really at the kind of like level 4 is really trusted data pipelines, a way for us to actually verify the integrity of the data that we are ingesting. For example, if we are going to use on-chain data, is data coming from, say, Infura or Alchemy API trustworthy? Is it possible that data that I get from an RPC endpoint can actually be incorrect? So what, in that case, how can I actually ensure that my data is correct? Is there a way for me to actually verify that the data that I get from the RPC endpoint is indeed the actual data that is found on the blockchain, and not some stale data, outdated data that I get from the RPC endpoint? And in certain cases, for example, when I'm getting data off-chain from some centralized exchange, for example, for pricing, or I'm scraping some data from a forum, or from Twitter, or from some social media, how do I know that the data that comes from it is actually correct? This is where, again, like solutions such as technologies such as TEs or even like ZKTLS would come in to provide this way or this primitive for us to verify the authenticity of the data that we are using. So now that we have kind of like verified the core of the AI agent and all the outside inputs to this AI agent, we are done, right? Not really. So at the very last level, I think this is the thing that is really hard for us to do. Because the AI agent itself is autonomous, like we have established earlier on. And since it's autonomous, decisions are made on behalf of us based on our goals by the model itself. So how do we know that the model is kind of like doing the actions that is aligned to our goal? This is actually the alignment problem, and it's an open problem even up to now. Like it's an open research problem. There are a lot of smart researchers in the world that is working on how can we verify or how can we prove to a certain extent that the model, the decisions made by the model are actually correct. The model itself is robust. The model is not susceptible to prompt injection attack. The model won't suddenly one day go crazy and does the exact opposite of what I ask the model to do. So in this case, of course, like the verification of the model itself can be done hopefully in the future by using some clever kind of like techniques. But now, how can we actually do it now? How can we kind of like have a certain level of alignment for this autonomous AI agents, given that we can't verify the correctness of the model in its entirety? This is where I feel that by kind of like breaking the AI agents into separate modules and defining clear, because now we have each module that is actually a small functional unit, it's easier for us to actually define what is the correct behavior, what is the boundaries of the behavior for all these modules. Think about it as like, as a human being, we have laws that define what we can do and what we can't do, right? And the thing is, you might want to do certain bad things, but because there's a certain law there that says that you can't do it and therefore you don't, or like I don't, that to me is actually good enough because the kind of like the actual bad effect is not instantiated into the real world. So in terms of like level 5, where we are kind of like establishing the correctness of the decisions and the models, I feel that this is a worthy goal for us to achieve, but currently, like what we can do really is to establish rules or boundaries on what can and cannot be done and enforce it for our models. So with that, we kind of like move on to like proof of agents with TEs and how we can use TEs to do it. I've actually touched on it like earlier in my presentation. TEs provide us with confidentiality, integrity, and we can make use of it to perform like to provide attestation of the proofs of the environment of the model itself. And we can make use of the TE to actually enforce the rules that we want, the boundaries of what our model can do. And if you think about it, let's go into something more concrete. Like, for example, how can we prove that the model is indeed correct? We can use, like, in general, 2 ways. We can prove that the model is using a specific model through a TE proxy, or we can directly just run the LLM within a proxy itself. And what this allows us to do is to kind of like have this ability for us to verify that, hey, the request that I'm sending out indeed comes from, say, ChatGPT, or indeed comes from OpenAI, or from Anthropic, or from any other LLM providers that you would want to use. Next, I can actually run an LLM in the TE itself. And this again, there are 2 ways on how we can do it, like remotely. This allows us to run 671 billion models in the cloud. I mean, if you have the money to actually pay for it. instead of running it on our home machine. And because it runs in a TEE, it doesn't matter if you actually own the hardware or not. You can have confidence on the confidentiality and the integrity of the model. Or you can just run it yourself locally. You can buy a GPU, put it into your desktop system, and run the model locally. And one thing that is very interesting is actually like all of us here have a TEE. Our phones actually have most of our phones. If you have an Android phone or an Apple iPhone, you have a TEE that's running in your phone. And we have actually tried running certain lightweight models. For example, 3.2 billion parameter Llama model on the phone itself, and to use it to actually perform certain tasks using ELIZA. If you're interested, I can share more. And kind of like, with all of this, the question is, what can we do? Why do we need these verified AI agents? One, the user have increased trust and confidence when they are using the AI agents. And two, we can actually provision services for all these AI agents. For example, we can provision free RPC access for AI agents. We can provision free transaction, like gasless transaction for AI agents. AI agents can have certain autonomy to select for certain charities, maybe in the future. So I think these are all very interesting and nice use cases where if we are unable to verify the AI agent, we are not, or there's a very high level of risk if we want to use the AI agent for all these use cases. I'll kind of like skip this. So really, TEs bring to AI agents kind of like two main things: confidentiality, integrity. And by using that, we kind of like, we can ensure the autonomy of the AI agent, that there's no backdoor, that it performs to a certain extent what I want it to perform, and it shouldn't do to a certain extent what I don't want it to do. With that, that comes to the end of my presentation today. We have some socials and stuff like that. So thank you. Thank you for your...
Thanks, Zhen. Okay.
Okay. Does anyone have any questions? Nope, thank you.
Okay. Thanks, Zhen. And for our final talk today, Tom from Linium is here to show how we can build private AI apps using MPC and TEE. Yeah. Welcome.
Hello, everyone. Thank you very much for being here on the last talk. I know it's been a rainy and big day for you guys. So my name is Tom. I work at a company called Nilian. And to be honest, I will not be talking about Nilian as much today. I want to talk around consumer AI products and privacy. So just as an introduction, I do developer relations. So I came from a marketing background in social media and then moved into software engineering, and then here I am. Previously, so what Nilian does in layman's term is orchestration for cryptography primitives. So PETs, MPC, and TEEs. And previous to that, I worked at a company called Wallet Connect, which is a very big layer in connecting dApps and wallets. So a lot of apps, major apps that we were able to interact with, so that was a lot of fun. And in terms of my personal journey, just to share and talk about why we're kind of going down the privacy route, and it seems like a lot of people here in Taiwan and traveling around the world really care about this. I think I initially wanted to start with decentralization, financial independence, and transactions that are on the open ledger and things. And then I moved more into kind of like Wallet Connect and the kind of user journey of, oh, let's do account abstraction and do all these things, which I think are awesome. And I think there are great things to actually get from that. But I think kind of where the world is heading is a lot more concern for what privacy is, which I'll touch on shortly after. So today as the agenda, once again, I won't be talking so much around a company, but more so asking a question and trying to understand why we need to build with privacy as opposed to just, going with current conditions. So I'll cover the current state of privacy, the PET primitives, so privacy enhancing technologies, MPC, TE, FHE, ZK. I believe in the last talk, TE was quite covered, so I don't think I'll cover too much on that. One second. And yeah, and then so use cases of kind of in the real world and in our Web3 world, and then more so around kind of the trend that we're seeing outside of crypto, but also can combine what we have here today. So I hope to be the guy to want to ask and get involved the audience. I know this two-part question. How many of you guys actually care about privacy? Please raise a hand. Okay. That's 80, 90%. And then the last question I really want to filter out on is how many of your friends, family that are not in the space care about privacy and cryptographic primitives? One, two, okay. I think that's the challenge. And I think we're all in this room because we understand ZK stuff, TEs and financial transactions and things like that. So like, I think, on the curve meme, we might be more on the right curve thing kind of situation. Maybe we're mid-curving with our knowledge. But the majority of people here and outside actually, I don't know, I don't think they really care about privacy as such. And I think that's the barrier that we as founders, developers, people in marketing and community have to care about. So left side is that we kind of, a lot of us here, 80, 90% of us, or 100% hopefully, care about privacy and, retaining who we are and our identity and things like that. But the other side is, and I was talking with my best friend who works in travel and tourism. He thinks privacy is a private Instagram account. So it's that's kind of, I'm not saying that's just the standard norm, but that's kind of the mindset what people outside of this industry perceive sometimes. And I think it was a good kind of step back, and I asked, hey, do you care about sign in with Google? Do you care about sign in with this? Or for example, do you care about uploading your family photo onto ChatGPT 4.0 image generate Ghibli style? He doesn't care. So that's kind of the spectrum we're on. Left side is us maybe, and then no, I think we're on the right side of the curve, and then left side of the curve is just the general population and how they think about privacy. Next. So just as a kind of recap of kind of what's happening in privacy. So the left-hand side is around 23andMe. They're a DNA company, and more so they've been in the media and the news. So very much so that, they're maybe not doing well in a business and financial operation kind of thing. And I believe the court was like, hey, you can kind of sell your data if you want to, and try and figure out how to run your business from there. Which for us in the room is pretty bad, right? Like it's not really something that we stand for and something that we'd want to see happening, of this being sold to big pharma and trying to do something and harvest that data. And then on the right-hand side, we have, I just Googled data breach, and we have some data breaches in Australia or in the US and different places. Everything, there's always a data breach here and there, whether it's enterprise level in terms of their security and encryption and things like that. And yeah, personally for me, not to disclose, but yeah, I've had my healthcare and my teleco and one more, my healthcare provider being breached with data. And what they do is they send me an email and say, hi, we're sorry, full stop. And so ultimately, that kind of sucks. They don't really care. Maybe they get a slap on the wrist, but that's kind of the state of privacy in the outside world of Web3. And so some of you might be familiar with what this was said. So yesterday I attended DIAC by Vitalik and the rest of the organization that organized that. And I hope I'm not paraphrasing or kind of changing the ways that he was trying to say things. But basically the three factors there is kind of what's happening in our world right now. Good for the best, for the better, and also for the worse. So mass communication is, say, how we're so hyper-vigilant and global citizens and we're all connected. But then AI, I love using AI, you know, but also it's kind of scary and I have existential crisis every single day. And then we also have biotechnology, so things like COVID really showed us that with hyper pandemics and the kind of situation that we live in. And then the kind of the underlined quote here is centralized security is a source of risk. And I believe he had a really good diagram to kind of all assist this kind of quote and statement. And that is because I'm not saying privacy is going to help, you know, mitigate the risks that come with those three factors below, but there are many elements of having secure databases and authentication and different ways to approach our identity that really matter with things like AI, previously mentioned around TEs, LLMs, and things like that, around mass communication. My normie friends, I shouldn't say normie, my normal friend is, you know, concerned around social, you know, how does his messages get leaked out and things like that. So that's kind of like just the trailing thoughts and I think a theme that people have been seeing with the theme of privacy, especially at this conference. And I feel like I really like this conference and people I met here because it is very cryptographic and privacy friendly. And what we have here is kind of an opportunity to kind of talk about that, which I really appreciate. So this is something I will come back to, and this is pretty much the only takeaway I want from my presentation today, of I think about this iPhone or Android toggle, and a lot of the things that we do is pretty much on the left side of public, and we just have everything public facing, you know, data breaches and things like that, and then, you know, all of our socials are kind of on the public and things like that. But I really want us, you know, for the people in the audience, I assume quite a lot of developers, is that I really want us to start kind of toggling the private mode. And the thing is, it's actually not that hard right now. I think if you go back 5 years around ZK and all these other things that these privacy-preserving technologies provide, is that it was a kind of bit harder. Even go back 20 years ago, it was much harder. So I really want this to be the only takeaway if you do remember what I talked about. And to kind of go on the theme of what privacy-enhancing technology, it's a great acronym. I was going to put some other dogs, but this is the first thing that came up of pets, anime. And then there is no relation towards any of these characters and the cryptographic primitive, but I just did it for convenience. So hopefully that makes things a bit more memorable. So this, I linked it below. It was a Mirror article I wrote a few months ago around pets. This is currently the current ecosystem. You know, I'm sure a lot has changed, and I definitely met a lot of people in the conference that should be added onto here. But this was a quick ecosystem map, and it's kind of what I like to do whenever I enter a new, not industry, but different niche, especially in the space, whether it's in AI or something like that. And we have the MPC, FHE, TE, ZK, and we have a subsection for MPC wallets. And a lot of us here on this map and many more extended are really doing awesome things, and which I will tie into AI. But yeah, everyone here on that map and furthermore are doing amazing things. And this would have been a much emptier map 5 years ago. So a lot of progress is starting to be made. And for those that know of him, David Shom is a godfather, an OG in the cryptography phase. And can anyone, or maybe I won't subject you to the audience, but this was written 40 years ago in one of his papers. And the highlighted part of tapping into data gathered in everyday consumer transactions can secretly conduct mass surveillance, interfering individual lifestyle, activities, and associations. This was written 40 years ago. I think that's pretty wild, and you kind of look into that in the current state of things if we talk about and relate it to the things that was in the centralized risk slide. But once again, to iterate, it was done in 40 years ago, which really represents kind of the challenges that he foresaw within the community that have kind of fruition, which is a bit sad, but I hope it's not too late. And I'm not sure of the context, and maybe you guys had a lot more with TE in the previous slide, so I won't touch too much on these primitives, but MPC, if you think about it, it's just written on the screen, but the easiest way to understand the millionaire is with the millionaire problem. So we want to see who is richer. Alice, say, hypothetically has $1 million, Bob has $2 million. How do we reveal it and say one is richer than the other without revealing the amounts, even though I just did? And this is pretty much the easiest way to kind of visualize it. It's spread amongst nodes and then put together. TE, I think the previous person did an excellent job on it, so I will not get too much into it, but easier to remember, Face ID and other things allow it to do programming and run it in a secure, I guess garden is kind of like the way I like to think about it. Zero knowledge, I think a lot of you probably have a lot of context. These are the conditions that you would probably need to meet zero knowledge technologies, and to prove without revealing any additional information. And FAG, computation is performed on encrypted data without decrypting it first. So currently the way that we do it is that when you have to transport data, there has to be a decryption, but this allows for different things. FHE kind of took me a while to get my head around, so there are various parts of it. There's like partial homomorphic encryption and different things. But the article that I linked has a whole primer if you would like to learn a bit more about it. And I hopefully will not continue to keep using so many anime things to kind of visualize this, but this is kind of how I like to envision and understand the pet stage as 3-tier. Some people think we're on the stage 1. Some people think we're on stage 3. I think we're kind of stage 2.5. A lot of the crypto primitives in the history of cryptography were created in the 90s and 2000s in research and discovery, and even earlier. I would say that was probably like the egg phase. But right now, I feel like we're in the present of production-ready pets for usage and composability. And I think this is my last anime thing, so apologies. So the fusion of pets, we just saw them all in isolation of different tiers and this and that. But what we can actually do is think about pets as kind of like, think about like having a dog and a cat and another pet, all in one garden in your house, and they're able to help you, right? There's different composability that we need to think about with these different primitives. So TE, ZKP, ZK-proofs, TE MPC. The one I like to spend more time thinking about is TE and MPC. So they're composable, and that's kind of the stage we're at right now. So hopefully this has given you a good primer into cryptography and the primitives of what's involved, so that I can tie it into the conversation towards the end around AI and consumer applications. And kind of in the use cases, I'm sure there are many more that I'd like to put together, but in the things that came to my mind, having come from a wallet and UX background in the previous job, is that a lot of MPC wallets are doing a great job. Just the three kind of like shares and shards, and then reconstructing it to sign transactions. In the ZK side, there's railgun, email, and even country-based identification to prove who you are, and also in MPC databases. So this is probably kind of a more cultural aspect within our space that I really want to nail in. Maybe it's more on a hot take or something, but I'm kind of sick of going around the crypto conferences and reading the slogans. We are an L1 powered by XXX, powered by this, and we can do 2 million, 3 million TPS. I think that's the wrong language. It doesn't make sense to, if we think about the people, there were two gentlemen at the front who were like, okay, my friends care about privacy. Those people will not understand these pet primitives that we just talked about, which is why I want to go back towards this of, I really want to kind of engineer a part of our language and maybe the way that we build things to be a bit simpler in the terms of public and private, and kind of taking back the values behind it, as opposed to selling it as ZK this, TE this, MPC this. And I think we're getting there, and that's what I really want to hone into it, is that I think the better that we can do the developer experience, and of course with the marketing and the language of how we talk about it, is that we can get into the more freedom of what privacy stands for. So I hope to tie this now in. I hope it's been good enough primer. This is me thinking around the stack of what it is to build a consumer-facing business at the moment. Think about I don't know, an app like Tinder or something. If you think about it from a technical perspective, this is all you kind of need. I'm sure I'm missing a lot more, but this is hypothetically, if I'm at ETH Global Hackathon and I need to think of how do I build something, this is how I think as a developer. And right now on the right-hand side is some graphs. There is a very popular database called Supabase, which is heavily used by many developers. And on the right, I didn't put the label, but it's a company called Replit. And the reason why they're hockey growthing in the last quarter, say from November, December 24, is the AI hype, LLMs, and the readability that it has provided to really hockey chart and get people to use things. And that's kind of what I want to kind of tie into. So a lot of these people, a lot of the people building on AI stuff, there's I watched, if you guys follow a channel called Fireside, he calls it the vibe coding virus. And a lot of us has started to vibe code. And this is, to be honest, why the LLM side and also the vibe coding element has really pushed forward our ability to be able to make consumer applications. And I will retract the word consumer. I think I'd like to just call it applications. I think in this industry, we're trying to be like, we're going to build the next consumer application that does this. Just call them apps. But this is basically what the AI world has kind of allowed us to do in the past 6 months. And it's really impressive. I encourage you guys to play around with it and see what you can build, even if you are from a non-technical background. So this is kind of the stack that I think of, and this is kind of what is being reused, and people are being able to really make cool things and cool projects. And what I want to think is this is the private mode of right now, we can really use the APIs. The primary APIs that people are using in the AI world are these Claude and OpenAI and all these other things. And what we can do, and I won't touch too much on it, is the model side of things. We can run private models in TEs and really kind of keep the prompts and as well as like the security of it quite tight. We can do databases. The database that we run is with MPC and it's just a MongoDB. Just think of it as like private MongoDB. So like these are the kind of things that are happening within the stack that is being used every day. Authentication with ZK is, possible. Analytics, I haven't seen as much, but I have seen private analytics. So this is the stack that's been unbundled. And I want to bring about just a thought exercise about this, of this phenomenon that we had the other day. So if you think about, if I wanted to build this Ghibli style image anime generator, you needed primarily 3 things. You needed an authentication to maybe Google or something. You would need the OpenAI 4.0 image generation API, which isn't available. So I think people use like Gemini or something else. And then you needed a database to store the files and retrieve them if you wanted to. Pretty simple stuff as part of the stack, right? So we go back to here. Supabase would be the database. authentication would probably be sign in with Google, and then the UI would be spun out by V0, Lovable, or Bolt, and the API is /chat completion with an OpenAI or Gemini or whatever. But then I want us to think of this toggle, right? Private auth, private AI, private databases, same product. So we didn't really compromise, we don't have to compromise on what it is. I will give a caveat, speed is a bit of an issue right now if I want to put on this toggle, but it is there, it is available. And I think that's the thing. So with private auth, you can use ZK, private AI, you can use, you can run the model in TE or offline and things like that. And then we have private databases, which are possible with MPC. And yeah. So I think I have a little bit more, but once again, I just really want to hone in that I think building consumer applications right now, and I really want to encourage like people in the space and the community in general, is that let's not just build the next Uniswap clone with ZK and this and that. I think it's better that we start thinking of, okay, what is it that our friends want to use, and how can we just abstract it in public and private mode with the primitives that we have, because then people will care. Because think about it, like sign in with Facebook. I don't think I cared about it the very first time it came out, right? So we've gone into a very different stage of technology right now where we have to consider the need for the user if they want public and private, and I really want to encourage that. So this is just a very simple diagram. We also do LLMs inside a TEE, but I think this was previously mentioned, so I won't spend too much time on it. But if we tie it into the whole Ghibli example we had, the normal flow of the Ghibli would be, you would say, I want a cat jumping in my house in Ghibli style, LLM server, and then response. On the private side, it's a bit different, and all of that is within a secure enclave. So in summary, I hope you guys learned something and were able to take away something around the crypto primitives that we have readily available. They're pets, they're very cute, some weird acronyms, but privacy is here to stay and moving in a positive direction. I think it was already here when Monero came out and things like that. But in terms of consumer and developer and marketing and community, I really think it's a place where you can just hit the button and start doing it. But let's just not say we're a ZK protocol that does X, Y, Z. Let's try and frame it in a better way. The future of privacy lies not in a single solution of just using one of the primitives, but maybe thinking about combination. And I still think that's a bit of an experimentation phase. And really, I want us to think about the toggle. I really hope that's the main takeaway of that we can really build privacy consumer apps with the same features and same ability of Web 2. So I think that's it. That's just my Twitter if you want to stay connected. But thank you very much, and I hope you have a good evening. Cheers.
Thanks, Tom. And a huge shout out to all our speakers this session. And before we wrap up, just a quick reminder, tomorrow we start at 10 a.m. And we're kicking off with talks and panels all around public goods and open source, including a keynote by Vitalik and panels featuring voices from Litecoin, Code for Japan, and more. And don't forget to bring your badge, you'll need it to check in. That's it for today's session. Thanks again, and see you tomorrow.